hardware and the architecture. I mean, one controller may have different machine cycles for one instruction, some other may have different machine cycles. So accordingly, it will vary. Now, how to calculate this machine cycle? It's very important to understand this concept. We'll take one example. For example, I told you yesterday that the most widely used crystal frequency is 11.0592 megahertz. Okay. Now let's say 11.0592 megahertz is the frequency. Now how to calculate the machine cycle? That means how to calculate the total time it will take to execute one particular instruction which has got one machine cycle. For that, it is important to understand that the older versions of 8051, they had 12 clock pulses. So what we do is we divide this frequency by 12, and that means for one clock pulse it will be 11.0592 megahertz divided by 12, that is 921.6 kilohertz. Okay, please try to understand what I'm trying to tell you is that the older version, that the original 8051 had 12 clock pulses in one machine cycle. So for one clock pulse, it will be the frequency divided by 12, that is 921.6 kilohertz. So we know that this is the frequency and time is the inverse of frequency, so that will be 1 divided by 921.6 kilohertz, that is 1.085 microseconds. So 1.085 microseconds is basically the time it takes to execute one instruction. Sir? So we have with us our expert for today, Dr. Baban Kumar Bansoor. He is Senior Scientist in Central Scientific Instruments Organization, Agrionics Department. Dr. Bansoor is basically an electronics engineer, and he did his PhD from Thapar University and postdoctorate from Richard Russell Research Lab in Athens, USA. Dr. Bansoor has a vast experience in the development of sensing and instrumentation in the field of agriculture. He was the project leader in several projects, and he has successfully implemented all these projects also. And I hope you will benefit from his rich and vast experience in the field of embedded systems. Over to you, sir.
Thank you, ma'am. And thanks a lot for so gracefully introducing me. I think let me load my PPT and then we'll begin today's talk. So, can I?
क्या है इसमें?
PPT.
किस नाम से? आप इधर
Is my PPT visible to audience? Okay. Can I stand up also? Standing up में भी हो सकता है कि बैठे? Both positions are okay. So we have chalk. Do we have chalk?
So then we can move this laptop to podium.
Sorry, Ferenc, for all the interruption that we were having during this loading of the PPT. Well, today's talk is on real-world application or industrial applications of microcontroller, that is embedded system. And I'll be mainly talking about the food sustainability. So therefore, I had to load my earlier PPT in which you can see this front PPT. So basically, my main research is in the areas of food sustainability, and the snapshots of what I'll be covering includes abstract of contribution during my career span, sustainable food system and challenges that we have nationally, internationally, introduction to my domain, wherein I have been working from last 15 years, background of earlier research that is carried out, and some designing of some embedded system for determination of moisture, oil sensing. We'll also try to see chemometric sensing. But well, before we do that, I would like to understand from you, Melissa, what is embedded system? Because before we actually start building the complex system and get into the design aspects, so let us firstly understand what is embedded system. So I think by now it has been already covered. I'm not aware what has been covered and what has not been, but let me put these questions and let it come from you only. What is embedded system? Yes. Audience, remotely seated audience or local audience. What is embedded system in your name? I am not familiar with anyone.
Maharashtra Polytechnic.
Okay, Maharashtra Polytechnic Bid is there, and who all are there? Let me know who are there other than Maharashtra Polytechnic in Bid.
Polytechnic we have MMU Nana.
Okay, Polytechnic. This is the list.
Yes, and Merit.
Okay. So any one of you voluntarily, all of you are welcome to answer my question on what is embedded system in your definition. Any one of you. Any one of you can initiate. Maybe this Polytechnic from Beat, Maharashtra. You can take lead. Yes. Please go ahead.
It is a combination of hardware and software.
It is a combination of. Yes.
Hardware and software. You can operate the hardware using the software.
Combination of hardware and software. Is it that? Am I right?
Can you like switch off that external mic and use internal mic instead?
I can use the internal mic only. That will be better. You are not very optimal, but what I have heard is combination of hardware and software, right? Yes or no? Yes. Polytechnic, Maharashtra. Okay. So, anyways, any other definition? Maulana Institute.
Sir,
What is embedded system? We are discussing right now what is embedded system.
basically, sir, it's a combination of electrical and mechanical devices.
Yeah, combination of electrical, mechanical devices. That is what embedded system. College, Jaipur. Jaipur Engineering College. What is embedded system? Okay, if not, then Maharshi Markandeshwar University, Maulana. This is already over, I think. Okay, JIT Jodhpur. Can you define what is embedded system? Someone said that it is combination of electrical and devices, and that is embedded system. Other from Maharashtra said that it is a combination of hardware and software. Any other definition that you have from Jaipur, Jodhpur?
Hello, sir, from KIT Jodhpur.
Yes, please go ahead.
Sir, it is a software controlled hardware.
It is software controlled hardware. Very nice. And now you can see that we are coming out with a different definitions. They are meaning more or less they are meaning same. But I would say don't mind it. All the definitions are incomplete, and so they are not complete. Basically, I would not say that they are wrong, but they are incomplete because in one way, okay, I'll define it. Embedded system is a combination of hardware and software. And when we talk of software and hardware means it can be electronic. I mean, it will be electronics as well as mechanical also. It includes mechanical also. Okay, and software is going to be there. Definitely, it is the heart of the system. But if I stop there, then it won't make any sense. It is a not only combination of hardware and software, but this combination of hardware and software, it is meant for some dedicated purpose. So if you miss this keyword that it is meant for some dedicated purpose, then the whole purpose is defeated and the definition remains incomplete, because nothing in this world is done or developed or designed without any purpose. So there is a reason for everything that we do. We learn engineering, we learn anything, or whatever is happening in this world has got some purpose to it. So embedded system, if we define in this manner, it remains incomplete. But unless you add the word that it is meant for dedicated purpose, for example, you have elevator. There are a number of applications in real world, right? And you all are aware of it. Let me list out here. These are the applications in various variety of applications. Like there is consumer electronics. There are in consumer electronics you have TV sets, compact disc players, video players. In day-to-day our life routine, we come across so many embedded system devices, and I would say that our life is not starting from the morning that we put alarm in our mobiles. That is embedded system. We get up, then we take breakfast. There is a microwave oven. Okay, we go to bathroom for bathing. There is a geyser over there, which is again an intelligent device. Then we do something. We go to our car. We reach the office. Car is also using so many. It is embedded system. So many intelligent things it has these days. And in office also, when we reach, we switch on the air conditioning. That is also an embedded system because it has got inside it that intelligent part to it. So everything that we are doing these days, it is an embedded system. Without embedded system, we are unable to start our day and end our day. So whether we are starting a day or ending a day, it is without embedded system. So whether it is day-to-day life, or whether it is agriculture, whether it is launching satellites, launching missiles, anything you talk about, whether civilian applications, environmental, energy applications, smart energy, smart grid, a smart management system, energy conservation, rainwater harvesting, or anything you talk, smart classrooms, smart cities. So anything you talk about is an embedded system. Okay, and then defense applications, strategic applications, automotive. So you can see here there are a number of applications that I have listed over here, which includes consumer electronics, automotive, appliances, then point of sale systems. Point of sale system. For example, if you are traveling in a Volvo, or these days even in the trains, then what happens? They come to you with that POS, point of sale devices. So those devices, they give you tickets or something like that, and they're all networked. These are all Internet of the things, anytime, anywhere. any place. So they are all connected. So they are network, crowdsourcing, cloud computing, that is all integrated inside it. So these are point of sale computing at remote places, and this is the solution that the kind of country like India, which is a developing country and consisting of highest population of the world, almost after China, and shortly will be also surpassing China, needs this kind of solutions. So there are different embedded system applications, which includes all these listed over here. Then even your computer peripherals. We say that basically, let me go back to some history also. Your computer peripherals, whether it your computer or laptop, it is also an integrated embedded system, you can say. In fact, it is a combination of number of devices which are peripherals which are part of it, and computer. A general purpose computer is again formulated out of number of embedded system devices which are connected together to perform a general purpose application also. And these days, in fact, it becomes very difficult to even separate out which is a general purpose and which is not a general purpose. For example, your mobiles. Mobile, for that matter, till recently we used to call it an embedded system, and now also we are calling it an embedded system. But these days, if you say, going with the basic general definition, that embedded system is meant for a dedicated purpose, whereas your other type of computers like general purpose computers, they're general purpose, they are not an embedded system example. But looking at the today's mobile, you can even do your slideshow, you can typing word processing part of it, Excel sheets, and so many things are available to it. So that is the beauty of the today's mobile, and in that case, I don't know to what extent we will be able to call it an embedded system example. So anyways, so computer peripherals, whether your mouse, this mouse is able to intellectually interact with the computer, which is a wireless mouse. It has got inside it, there is intelligent brain in it, there is a processor to it which actually communicates and executes all the protocols. So whether it is hard disk, that is also intelligent because it is saving the power, it is doing everything very intelligently. So everything is embedded system, computer peripherals, as I said, laser printers, color monitors, and these are all your printers also these days. They have got so much of versatility and functionality to it, and it has become possible only because of an embedded system. So sorry. Then there are development tools. Yes. Are you trying to say something?
Hello.
Yes. Please go ahead. You want to say something? ITM Gurgaon. ITM Gurgaon. Yes, please go ahead. You want to say something? Okay. So I'm again continuing. So development tools also. In fact, for developing the embedded system, we are using number of hardware and software tools. And those tools itself, they are using number of microcontrollers to it, and they themselves are actually embedded systems. For example, we have got single board computers, AP-ROM, programmers, emulators. So while they do some particular job, emulation, simulation, debugging, and all these in circuit application programming, in system programming, they are using some sort of embedded system principles and techniques to it. So therefore, it is also an example of embedded system. And measurement equipments, whether you take multimeters, earlier it was just measuring, but now it has become much more to it. There is much more to it because everything you need now more. So you need everything in more. So therefore, it required integration of the intelligence to it, like microcontrollers to it. So multimeters are not only now measuring current, voltages, but they are performing much more other operations like giving you analysis, storage,
Hello.
connectivity. Yes, ITM Gurgaon, please go ahead. We can hear
Hello.
you. Yes, please. Connectivity problem है? हाँ. So today what we are going to do is we are trying to understand what it is, how it is, and then how different real world applications,
Hello.
industrial applications can be developed.
माइक म्यूट दिखा रहा है तो वो में वॉइस नहीं आ रही है.
Voice नहीं आ रही है. Can you hear me now? अभी आप सुन पा रहे हैं?
Hello, MMU Mulana. हेलो MMU मुलाना,
हाँ जी सर, अब आवाज आ रही है आपकी।
आ रही है आवाज?
हाँ जी, हाँ जी।
हेलो सर, सर बिल्कुल ऑडिबल है, क्लियर है आपको ऑडियो?
हाँ जी, हाँ जी, क्लियर है सर। ओके, थैंक यू।
So again, going back to the application, so therefore we would like to see the applications, what are the design considerations, hardware, software design considerations, and then I'll be taking you to the real world where we have developed some food sustainability related solutions and developed some projects, real world programs. So now measurement equipments, coming back to the applications, oscilloscopes are there, logic analyzers are there. So they need all these in the embedded system related things in order to make it more versatile and more useful to the required application. So I think we have already covered the definition of embedded system. Now what is system? System, what do you understand by system? System is a way of basically working, uh, organizing or doing one or many tasks according to a fixed plan, program or set of rules. So in any system, whether you know it is an institute or embedded system, it is a way of working, organizing or doing one or many tasks according to fixed plan. So here are the details, and a program under a certain program or set of rules, that is a system. And or we can say a system is also an arrangement in which all its units assemble and work together according to the plan or program. So that is what embedded system is doing. It has got assembled number of components to it, which we call hardware, and then it works under some particular ambience, a particular environment and set of rules, which is called as software to it. That is the operating system to it. So that is what is called as system. And there are some examples. Now through example it is better to realize what is the system. For example, watch. See, what is watch? The function of watch is it is a time display system. Okay, it displays the time. And what are the parts of the watch? Parts are, there is a hardware, needles, battery, dial, chassis and strap. So that is what makes it a system, and there are parts to it, hardware parts to it. So these are the examples of some systems. Okay, and then there are rules. Now this works under some rules. What are these rules? All needles, they move clockwise only, right? A thin needle rotates every second, a long needle rotates every minute, a short needle rotates every hour. All needles return to the original position after 12 hours. So these are the set of rules under which they operate, and that is how it makes a complete system. So there is hardware to it and there are set of rules to it. So this is how any system works. So we are seeing some examples and then we'll try to relate it to the embedded system development. So there are a number of examples, like again there is a washing machine, and washing machine is again a very good example for that matter as far as the embedded system goes. And in washing machine, what is there? It is an automatic clothes washing system. And what are the parts to the washing machine? There is a status display panel. There are switches to it. There are switches. There are dials. There are motor, power supply and control unit, inner water level sensor and solenoid valves. Without these parts, because in system there are number of parts, and without and as we have been seeing, we are trying to understand the logic of embedded system, that there is a hardware and then what extra is required in order to build any system. So there is a hardware part to it and there is a set of rules to it. Now what are the set of rules in case of washing machine? There are set of rules in which it works, which we can call as a software in case of embedded system. So these rules are wash by spinning. So what happens? There is spinning action and there is a rinsing. So while you wash the clothes, what you essentially need is spinning, you need rinsing, you need then after that drying. Okay, and wash over by blinking. Each step display the process stage. Then you also want to have interaction with the users. So for interaction with the user, you need to have some display status through maybe through indicators, some LEDs, or maybe through LCD displays. There are some messages which are flashing or rolling over. So each steps display the process stage, and in case interruption, execute only the remaining one. There is any interruption, for example, you want to stop, somebody reached at your home and you want to stop the operation or you want to leave to the market, you will stop it. You may switch it off also. So what happens next time you again switch it on, it will start from there only, from the point where you ended that operation. So last time where it finished, it will start from there on. So that is called as interruption. So there are number of rules under which any system works. So this was the example for the washing machine. So therefore, again, I am coming back. The definition of an embedded system is one that has computer hardware with software embedded in it as one of its important components, and this is meant for some dedicated application. So basically, whatever parts are there, these are all computer peripherals. Because as I was trying to explain to you, if you go back to the history, then the same design engineers who designed microprocessor actually felt a need of microcontrollers. Okay, what is the major difference between microprocessor and microcontroller? Do you know? CPU. Yes. So very nicely said by Vikas that microprocessor is only having a CPU. There is a processing to it. Okay, there is processing, there is arithmetic logic unit, there is a control unit which controls the sequencing of the instructions to be executed. Arithmetic logic unit performs that arithmetic and logical operations, and then there are working registers, as you know, register A, register B, which actually are required for processing. So that is the processor. So the design team engineer from Intel's, the one who developed that microprocessor, felt a need for, initially they developed 4004, 4-bit processor. Okay, this was 4-bit microprocessor. Then the same design team felt need of having then later on, of course, it went for 8-bit and like that. But what happened in real world, they realized that there is a need for the peripherals. Because anything that you do, for example, any brain anybody is having, what for it is? The processor that you have or brain that you have, it is meant for interacting. Like we have brain, and if we don't use it, we don't interact with the real world, there is no use to it. So processor, unless you interact with the real world, there are input-output peripherals. So we have hands, we have legs, and we are interacting with the real world, and we are performing some job. So processor is meant for something to perform some real world job. So therefore there is a processor, and they felt that this is only processing, this is only brain, but what for? There is a purpose to it. We need some cost, perform some requirements, some work done should happen. So for that, they felt that there should be input IO peripheral should be there. There should be interaction. In case of microprocessor, if you can recall, we connect the CPU processing to the external world through one chip. For interfacing with the IO peripherals, we use one chip. What is the name of that chip? Have you heard of that chip? Programmable Peripheral Interface, PPI. Am I right? So it was used for the purposes of there is a processor, and to interact with the real world, these are the input-output peripherals. Okay, peripheral adapters. You have got something like that, some interfacing chip which understands the handshaking signal and IO operations and something like that. Control logic is to be sent, data is to be sent, address is to be latched, and all that. So there is a PPI chip which actually takes care of all this. So that was the case of the microprocessor. So what they felt, because you see, need is the mother of invention. Even the whole human being, the evolution happened because of the need. Okay, so therefore from microprocessor we migrated, we graduated, and we advanced, we developed towards the microcontroller. So new thing came into existence. Same Intel's chief design engineers developed microprocessor 80. कौन सा था सबसे पहले? 31. Okay, I think subsequently it was followed by 51. So initially this was launched, I think something around 1970s or so. The same design team engineer felt need to have a controller which is actually having inbuilt processor to it. Every microcontroller has inbuilt microprocessor to it, and besides microprocessor, it interacts with the external world through the IO peripherals. So it has got the ports. So there are ports to it. What you essentially need in the microcontroller is there are ports. So if I am required to draw a diagram, I'll just show you here. Here, So you see, this is the microcomputer. This is called as microcomputer on a chip. So what is done here is, same design team engineer felt that microcontroller, which is having now microprocessor inside it, RAM is added to it, ROM is added to it, because while you perform any operation, you will need some memory. So, and what is to be performed is stored into the ROM. So that is the brain, that is the brain memory in which the instructions are stored, because we also work based upon what is stored in our memory. There are impressions, there are thought process, and then we manifest. So it manifests through this RAM memory. Okay, so this is the working memory through which it happened. So they added in addition to the microprocessor, they have added RAM, ROM, and there is a programmable interface IO peripherals, peripheral adapter. This is for controlling. So when you add all this, and of course clock is required, which is a something like our heartbeat or pulse, without which we don't exist. So it functions. So like we have all the body organs, but our heart rate goes, we cannot work. So it gives that kind of pulse to this all hardware, and it works only if there is a clock to it. So that is the system clock. So through this you can see, and anything it requires address bus, data bus, and control bus, because to interact you need to either you'll communicate, you'll send the data, and for sending the data you need to address also where it should be sent. So there is a address bar also, bus also, and then how it is to be sent, because everything should operate under a particular boundary condition. There are some rules, constraints. So therefore you need to have control bus for sending the controlling signals. So this is how it makes a complete microcontroller. So that is how the invention of microcontroller took place. And so we were actually seeing here the definition, and then we actually went into the history of microprocessor and how we are evolving from microprocessor to the microcontroller. And here is now again the definition of embedded system, as we have seen that we have seen now what is the system, what is embedded system, what is the microprocessor, what is microcontroller. Although it was assumed that you are all aware of it, but I have just tried to give you a refreshing things of it, refreshing your knowledge on that. So therefore basically there is a software program which you can see here, software program in embedded system, and then there is a hardware. So this is a hardware, and then what happens is this software, you burn that software into this hardware which is meant for some dedicated application. Okay, so that is what it makes an embedded system. So in order to define an embedded system, how can I do it in a block diagrammatic form? So in anything, you take any system in this world, the analogy remains same, that there is an input and there is an output. So input can be through any form. The input is coming through either input sensor, there is a keyboard to it, or there can be sensor to it. So input is coming either through sensor or through keyboard. For example, in human system, the analogy can be like the inputs are coming through eyes, okay, visible input through ears or through mouth. So there are different inputs which are coming to us through different modes. So similarly, in case of embedded system, there is an input which we say that there is a sensor, and sensor, or that sensor may be keyboard also. It is giving some input, or it may be some let's say you are sensing the speed of the motor. So there is an encoder, and the pulses are coming to the system. And whatever input is coming, what happens if I am quoting the analogy of the human being, it is going to the brain. So there is a processor to it. So input, so therefore the central core of the system, heart of the system is the processor, to which all inputs are going, whether through the sensor or through the keyboard or any other peripherals for that matter. And then what happens is that processor will perform the operation, it will take the decision making again based upon whatever is inbuilt firmware is there, and that applying that all logic and rules, then it will exhibit the decision. So it will manifest in terms of the actuation. So actuator happens like our brain processes, and it says that okay, हमारे सेंसर ने सेंस कर लिया, मुझे प्यास लगी है, इनपुट गया, ब्रेन में इनपुट चला गया, and now my hands are operating, I go to kitchen, I take the glass of water. So that is how my actuator works. My brain signal actuates my hands. So similarly, in embedded system, the microcontroller basically performs all the decision making and applies all the set of rules and constraints, and then actuates. So therefore it is said that actuator. So what you can see in the gray color is the actuator part to it, and at the center of it is the microprocessor, which is the core, and the inputs are actually the sensors or maybe the peripherals. So that is how the embedded system can be defined. Now friends, in order to design real world application, whether it is strategic application, you are defining some missile related, you want to launch some missile and there is some real time operating system, embed system employed over there, or it may be a life saving things, maybe ventilator or something like that, or it may be something, let's say you are designing something that people recently, you know, what is happening is लोग जो है कार के अंदर ही सफोकेशन होके, you know, they are dying like kids, for especially छोटे बच्चे जो है कार के अंदर रह के ये हो रहे. So you want to design some new product for that, that it should be so intelligent कि कार के शीशे जो है बंद है तो क्या होना चाहिए, कुछ logic should be there, something should be there so that you can save it. So you can become entrepreneur by developing your own products. So उसके लिए you need to understand what are the different set of rules, what are the type of embed systems, because मिसाइल के लिए कुछ different type का structure होगा, architecture होगा for the embed system. छोटा सा कुछ एक मुझे रिमोट डिजाइन करना है, ठीक है, या मोबाइल डिजाइन करना है, या कुछ इस रूम का टेम्परेचर कंट्रोल करना है, कार का मैं जो रिमोट कंट्रोल लॉक और अनलॉक करने के लिए डिजाइन कर रहा हूँ. सो एवरीथिंग विल हैव डिफरेंट स्पेसिफिकेशंस. सो in general, theoretically, what is it? So what is the classification of embedded system? Okay, that's what we will also have a look at it. What is the classification? And then you see what is the characteristics of the embedded system, because unless you know what it is, you cannot design an embedded system. So we are seeing all the aspects. What are the design aspects, what is the requirement, and what is how the real world industrial application looks like. So we are trying to cover everything within this 1.5 hour. I think we still have some 45 minutes or so. So so what are the characteristics? See, how this is how it differs from your general purpose computer. The main thing is that it is a single function. Okay, it is single function. There is a complex algorithm to it. Okay, because of course everything comes at the cost. So while you optimize something and you gain something, you are losing on something else. So it is dedicated. For example, you are developing some program, some application using the general purpose computer. आपको readily available मिल जाएंगे इंटरनेट के ऊपर उसके programs, क्योंकि it is Windows based system. But the same thing अगर आप कोई open loop इसमें जाते हो, open ended system में जाते हो, तो उसमें नहीं मिलता, ठीक है. But if it is a Windows based program operating system, तो आपको readily VC++, VB में अगर आप कोई program develop कर रहे हो किसी application के लिए, आपको readily programs मिल जाते हैं इंटरनेट के ऊपर. But this is an embedded system which you are developing on your own, and it is tailor made for your particular application or particular requirement. It satisfies particular specifications and requirement. So therefore it is a complex algorithm which you are developing on your own. Fortunately, in fact, now it has been embedded system has been there quite for long. So therefore now it is also possible to get some standard functions and programs available readily on the internet. But still, so as far as the application is concerned, which we will see what are the real world type applications, typically in the areas of agriculture for food sustainability, they will need you to apply your own knowledge and develop your own complete algorithms and programs for that matter. Then user interface is required. User interface, you can define different user interface. For example, if you go to ATM, there is a touch panel which has got different graphical user interface. Your mobile, it has got different GUI. So every mobile has different GUI. ATM is having different GUI. आपका जो वॉशिंग मशीन है उसका GUI डिफरेंट है, आपका टेलीफोन जो एक्सचेंज होते हैं उसका डिफरेंट GUI है, पॉइंट ऑफ सेल जो मशीन से उसका डिफरेंट GUI है, मिसाइल का कुछ इंटरेक्शन करते हैं, इसरो अगर कोई सैटेलाइट लॉन्च कर रहा है उसका कोई GUI बनाया होगा, कंट्रोल पैनल उसका GUI डिफरेंट है. सो एवरीथिंग हैज गॉट डिफरेंट यूजर इंटरेक्शन इंटरफेस. सो यूजर इंटरफेस इसके अंदर है. सो दिस इज आल्सो वन ऑफ द कैरेक्टरिस्टिक्स ऑफ embedded system. Then you see there are constraints. The main thing of embedded system, you can say, you can define embedded system ki why embedded system existed. What is the main characteristics of embedded system? Power, cost and space. If you wish to develop something which is very compact, चाहे मोबाइल हो या रिमोट हो, anything, if you are trying to design something which should be very compact, you cannot think of using a general purpose computer for that matter. चाहे आप लैपटॉप का भी सोच सकते हैं, right? Because लैपटॉप चलो 10 इंच का आ गया, 12 इंच का आ गया, still it has got some bigger size to it. So but if your requirement is very compact, very compact, you want to have space efficient, space saving design, then you cannot avoid thinking of embedded system. Because embedded system में यही है कि आपको cost effective, space effective and power effective. These are the three important attributes of an embedded system. तो आपको अगर space effective, आपका concern अगर space है, you want to design a very compact thing, so there is no other alternative than going for the embedded system. Secondly, you are developing something which is going to be operated at a place wherein the power is a great constraint. Maybe at some remote end, you are in a jungle and you are operating with GPS. Okay, GPS or for that matter any other tracking device, or for that matter even your mobiles. These days, before you buy any mobile, what do you see? Oh, बैटरी कितना है, 4000 मिली एम्पियर आवर है, 3000 मिली एम्पियर आवर है, एंड कितने दिन चलेगा, 2 दिन चलेगा, 3 दिन चलेगा. So because buying something iPhone and somebody you are buying Nexus and you are buying some Samsung, so mostly firstly many of you if you are interacting among, you will put a question, कितना दिन चलता है, शाम तक चल जाएगा, 2 दिन चल जाएगा, कितने घंटे टॉक कर सकते हैं. So that is a immediate, I think, one of the important consideration that you make. So similarly is the case with any other portable devices for that matter. जो pod है, portable operated devices जो होते हैं pod, they all need power efficient things. So अगर आपका constraint power है, again you cannot think of, I mean you cannot avoid thinking embedded system other than embedded system. Okay, so आपका अगर power is a constraint, आपका space is a constraint, and memory is again one of the constraints. वैसे power, space और नहीं, पावर और आपका क्या अभी देखा हमने, स्पेस देखा, पावर देखा, और एक है इंपॉर्टेंट कंसिडरेशन, कॉस्ट भी है. सो अदर मेन तो थिंग, ओके, पावर, स्पेस, these are the two important considerations, okay, which will require you that you should be going for this. Then cost and memory are the constraint. ये constraint थोड़े से अलग टाइप के भी है. Cost effective तो obviously it is going in the positive side, favorable. I mean it is again something that embedded system is only able to achieve. So वो भी उसमें है. जितना cost effectively you see, 5000 में आपको 1.2 gigahertz, quad core, octa core, this kind of things are coming into market. So you see, imagine the power, and as soon as you switch on the kind of Android systems, आप general purpose computer on करो और mobile on करो, mobile switches on and starts working within few seconds or minutes. But computer को on करोगे वो booting चल रहा है, and it takes 5 minutes. So there is a lot of difference. So therefore there is a lot of difference in terms of operation and speed also. तो memory जो है, but memory is going towards the negative side to it. Memory का क्या है कि if you are developing a complex system wherein you need bulk of memories, memory for that matter, उसमें भी advancements, there are so many advancements कि memory आपको अभी initially when we started developing the embedded system, we were using 32 MB, 64 MB, 27C, 512 kind of chips, or 27C, 256 kind of chips, 32 MB, 64 MB, these are the ROM chips, and then 6256, 32 MB RAM chips. So these were the highest number of, highest order of the and the capacity of the chips, memory chips that we could think of. But now it has been possible to go for the 128 kilobytes, 128 megabytes, and in fact it is also possible to go higher than that. And but theoretically again the memory is a constraint as far as the embedded system is concerned. Why so? Can you answer me on that? See, memory, एक अगर 627C512 एक चिप है जो 64 किलोबाइट्स तक करती है, ठीक है. तो ये जो 64 है और 27C256 जो है ये 32 कर रही है. अब इसका लिंकेज है, आई एम टॉकिंग अबाउट इन टर्म्स ऑफ 8051, इंटेल्स 8051. इंटेल्स 8051 में कितना बिट का होता है? इंटेल्स 8051 कितना बिट का है ये सीपीयू? इसका वर्ड प्रोसेस 8 बिट का वर्ड लेंथ है, राइट? देन 8 बिट मींस इट कैन प्रोसेस 8 बिट्स एट ए टाइम, है ना, साइमल्टेनियसली, पैरेलल प्रोसेसिंग, इजंट इट? और इसका एड्रेस बस कितना वाइड है? 16 बिट. सो अगर आप वो 2 to the power 16 करते हो, so how much it comes out to be? 64K आ जाएगा ये. Okay, so that is where the linkage is. So आपका अगर वो it depends upon how much is the size of your data address bus. Based on that, your memory capacity is defined. Okay, therefore, but there are number of techniques also to advance or expand this kind of requirement. Okay, so therefore, memory is a constraint as far as the embedded system goes. But then you have now, and then memory in memory there are a lot of advancements are going on. Okay, there are different types of architecture: RISC architecture, CISC architecture, Van Neumann, Harvard architecture. I hope you are aware of this, because if I will start explaining that, we will be short of time. And in all this architecture, there is something to it कि memory के अंदर जाना है नहीं जाना है, how to access this fetching of the code and all that. So all that is different. अब basically जितनी भी advancements होती है computing world में, it is based upon the memory and CPU and semiconductor. कितने number of transistor एक chip के ऊपर आप डाल सकते हैं, Moore's law, all that. So advancements of memory क्या है पहले, and then speed, उसमें भी DRAM है, static RAM है, तो स्पीड क्या है मेमोरी का. सो दैट ऑल्सो गवर्न्स कि आपका कोर कितना पावरफुल रहेगा. तो पिक जितने भी एडवांस कंट्रोलर आ रहे हैं, तो दे आर एडवांस बिकॉज देयर इज अ डिफरेंट आर्किटेक्चर टू इट. और उस आर्किटेक्चर में क्या है कि क्या सपोर्ट कर रहा है, मेमोरी कैसी सपोर्ट कर रहा है, वो उसकी मेमोरी की स्पीड सीपीयू के स्पीड से मिलती है नहीं मिलती है. सो मेमोरी इज ऑलवेज अ कंस्ट्रेंट, एंड एडवांसमेंट्स इन मेमोरी इज एक्चुअली लीड्स टू द एडवांसमेंट इनटू द controllers. So advanced controllers are possible only if there is advancement into the memory and CPU and all that. नम्रता, हेलो. हाँ, मैं अभी लेक्चर में हूँ. आई विल बी फ्री आफ्टर 1 hour. वी कैन टॉक आफ्टर 1 hour. ठीक है. So these are the tightly. So you have to design an embedded system or design embedded system. Why we are seeing all this? Why we are trying to overview all this? Because while you design an embedded system, you have to understand what are the constraints. You just cannot go like that with the blind eye, and you cannot define any specifications or develop any real world applications, industrial applications or any other applications. So you need to know what are the tightly constraints. You'll have to look into all these aspects very closely. And then you also need to know whether the system that you are trying to develop, real world application, industrial application, is a real time or is not a real time. Because embedded systems are the reactive systems. Okay, they're made for the controlling job. They're peripheral controlling devices. Okay, mainly. They are also data intensive. If you employ the DSP to it, then data intensive computations can be performed. And even if you employ DSP, embedded system is not that only that you can design it using only microcontroller. You can employ DSP, you can employ VLSI, FPGA, CPLDs and all that. Still they all remain embedded system. And you can employ microprocessor also. So don't remain in the impression that only if you employ the controller, then only it is an embedded system. It can be with microprocessor, it can be with DSP, with anything. So now another important characteristics of an embedded system is they are reactive and real time. What do you mean by real-time systems? Yes, BEAD, Maharashtra Government Polytechnic. Can anybody of you tell what is reactive and real-time system? Which is an important characteristics of an embedded system, which we will be, which we should know while designing any industrial application.
A type of process which is a time-bound function.
Very nice, very nice.
Real-time system, and any system which doesn't require any time limitations, that is called as reactive system or controlling system. Okay.
So very nice. They are time-bound system. In single word, if I have to define that, they are time-bound system, and you have to define their all legacy and there are number of things to it. And now, what are the types of real-time system? There are hot real-time system and there are soft real-time systems. Okay. So in case of, there are two types of real-time systems. In one of the system, it is definitely time-bound. But in one of the system, which I am saying hot real-time system, what happens is doing the job in time is definitely important, and if it is not done, the consequences are catastrophic. The consequences of not meeting the deadline are catastrophic. That means they are very severe in nature. For example, you have to interrupt missile which is being launched, which is launched by some enemies, some country. If it is not intercepted in real time, it can be catastrophic. It can destroy. Basically, it has something linked to the life. So they are very catastrophic. So not meeting the timelines is very catastrophic. They are severe. There are severe consequences. You're in medical system, if ventilator is not working properly or something like that, so there not meeting the timelines is again a catastrophic thing. So something like that, in which the consequences are very severe and leads to, you know, even life, threatening to the life. These are called as hard type of real-time system, which are very you need to meet the timeline for sure. And soft real-time system, old real-time system or soft real-time system are those in which again meeting the timeline, they are again time bound. You need to meet the timeline. When it is said real-time system, that means it has to be in real time. They are time bound, but not meeting the time bound delivery or the results is not catastrophic. They are not severe. That is the major difference. So, well then, specific areas under embedded system design, there are number of areas in under embedded system: microcontroller, microprocessor based design, real-time system, multiprocessing system, distributed systems, embedded software architecture, devices and device drivers, FPGA based systems, accelerated embedded systems, IC design, real-time operating system. So there are number of areas in which embedded system design exists, and which we don't have to get into details. Just for the familiarity and awareness. Then, as I was telling that, if you are asked being an engineer, because now you will, all of you are either, you know, professor here, and your students will go to some industry, or he will be either self-employed or he will be going to some industry, and they will be asked to design some real-world application. So how will you design it? By assessing what is the requirement, you firstly should be in a position that where it is getting classified. So there is a different classification of an embedded system. Either, so it is based upon mainly complexity. So based upon complexity, I can say that my embedded system is a small scale embedded system. And what it means, small scale embedded system means it will be a single 8 or 16-bit microcontroller it will use, less complex hardware and software it will have, board level design, battery operated it will be. So these are the important features, attributes to the small scale embedded system. And restraints are, of course, there are restraints, because you will not be having full-fledged much more freedom in it. The memory will be restriction, power dissipation will be again important consideration. And of course, skill required in case of developing a small scale embedded system includes microcontroller, computer architecture, software design, detailed electronic design, data communication, control engineering, motor actuators, sensors, IC design. Because most of these skill sets are falling into a category wherein a small scale embedded system will be required. It may be industrial application or any other civilian application or strategic application, but it will be on small scales. Then if your purpose is not getting served using this kind of small scale characteristics, then you may have to migrate to the medium scale embedded system. Now what happens? Your complexity increases gradually, and you may have to go for the higher CPU processing, because you now this time may be looking for a higher performance. And how do we get higher performance? Either by increasing CPU word length. So it is it is 16-bit or 32-bit processor can exist. Like in one of the applications, we will see that now we use 16-bit PIC controller. Earlier we use in one of the in other application 8-bit controller, Silicon Labs mixed signal controller. So microcontroller can be used, RISC architecture can be used, DSP, application specific, and IP. It may involve use of RTOS also. Then distributed system, bus networks, encryption, and all this. So okay, and now again the last system is again based upon complexity, is the sophisticated embedded system. In case of sophisticated embedded system, this is the highest level of the embedded system that you may be going in for, maybe like in missile things or satellite launching or any other higher end embedded system wherein you may require multiprocessor communication. There is a distributed network, one network is like now we have smart cities, smart grid for power distribution. Therein you will need some multiprocessing system to communicate with each other. Safety critical applications wherein safety is a paramount concern. So you cannot wait. There cannot be any delays. Okay, you cannot think of delays. So safety critical applications again will need everything to happen in real time, and it will need higher things. Hardware software co-design. It may not be, because you can optimize not only by using hardware. Hardware systems are fast, but sometimes you may have to balance with the cost as well. And then sometimes your software design can complement your hardware design. So that is how you'll have to optimize it. So same thing, for example, you need real-time clock. In case of real-time clock, date, time, and these things, you may implement that using hardware as well as software. So it not necessarily, because or let's say UART for communication. UART can be implemented software wise also or hardware wise also. You know now these days have software designed radios, software designed radios. So everything is possible through software also. Of course, some basic hardware is required, but software driven radios are also now possible. So therefore, there will be hardware software co-design when you think of complex and sophisticated embedded system. And it will be mostly RTOS, real-time systems, like your ATMs. They are little higher end systems. So now let us sum it up. Components of an embedded system will include, there is a CPU to it, and there is the memory, ADC, sensors, actuators, DACs, diagnostic ports. There might be some emulation, debugging, and all these ports, human interface. So basically, in brief, I can say it includes input, output things. Is it not getting displayed over there? Here I am having something else. On my laptop, there is some other screen. It has not been transferred, shifted to next. So basically, there are different components of an embedded system, and input-output system. So components include your processor. Basically, why we are seeing all this? Because unless you optimize the hardware, you cannot design any real-world industrial application. So you will have to optimize processor to be used based upon what kind of classification do we have. Different manufacturers, they have different availability, starting from 8-bit, 16-bit, different cores, RISC core, CISC core, combination of RISC and CISC both, and then a pipelining architecture. So all these attributes are there as far as selection of the hardware is concerned. If you need timers or you don't need, SCI, interrupt controllers, parallel ports, memory, data program, output interface, etc., etc., etc. Power supply, reset oscillator circuits, application specific circuits. So all these are the components while you design the embedded system. Then components of an embedded system include software, which is application specific hardware, and series of tasks, constraints, available memory. So software will be designed based on series of tasks that you have to design, and you will have constraints, available memory, available processing power, dissipation limit, etc. In RTOS, you will have supervised application software, allocate resources, context switching, latencies, meet the deadlines, scalability. So what do you have? Basically, there is an application layer. Application layer, what do you mean by application layer? So for designing any industrial application, you will have application layer. There is a RTOS and there is a hardware. So application layer is something that you see at the top. Let's say your GUI, graphical user interface, wherein user is interacting, user is inputting something. So that is the application layer. Then in between the hardware and the application layer, there is some driver layer or RTOS layer to which it gets communicated. That driver further communicates to the hardware and it actuates. Then it actually comes into the action. So while you operate the ATM or your mobile, what you are doing here is actually getting communicated to the driver layer. So that driver is nothing but again a that is a core, that is a software core, some sort of software core, which actually interfaces your again the application layer, which is again a hardware. Let's say your touch screen is a hardware. So you are touching something, and there is a software designed to it, and then there is a inbuilt intermittent protocol, which is called as drivers, and which is RTOS, and it is getting communicated to the hardware in terms of actuation. So that is how the whole system works. So hardware components, you have processor in system. सारी फैमिली है, मोटरोला की फैमिली थी, स्ट्रीम वन, फिर इंटेल की आई, फिर स्पार्क सन एक था, फिर पावर पीसी आईबीएम आया, उसने एमपीसी 620 टाइप का एक मॉडल लॉन्च किया. सो एवरीथिंग हैज गॉट, तो इस तरह से इवोल्यूशन हुआ. एंड जनरल पर्पस प्रोसेसर जो है, अब माइक्रो कंट्रोलर जो है, इसमें लिमिटेड कैपेबिलिटी, एनहांस इनपुट आउटपुट फंक्शंस, एप्लीकेशन स्पेसिफिक यूनिट, इसमें जो है मोटरोला का 68 सीरीज का कंट्रोलर आता है. देन इंटेल्स का 8051 का, माइक्रोचिप ने पिक लॉन्च किया, और स्ट्रीम 4 जो है आर्म जो है. सो एडवांसमेंट्स कंटिन्यू स्टार्टिंग फ्रॉम इंटेल्स, एटमेल, पिक, मिक्स सिग्नल, आर्म, ऑल दिस. Then there are so many things, basically RISC versus 6, इसको कैसे select करना है. So why I'm explaining all these are all the design considerations. These are all the design considerations. So कोई भी industrial application अभी जो हम दिखा रहे हैं, वो इसके सिवा आप नहीं कर पाएंगे. RISC versus 6 में इसका भी हम डिफरेंस देख सकते हैं, but I would like to now switch to the actual application. उसका मैं आपको दिखा दूं कैसे होता है. But RISC versus 6 में इसका मैं टाइम मिला तो बताऊंगा आपको. But मेन है कि 6 जो है वो कॉम्प्लेक्स इंस्ट्रक्शन सेट यूज करता है, और RISC जो है वो रिड्यूस इंस्ट्रक्शन सेट कंप्यूटर है. रिड्यूस इंस्ट्रक्शन सेट कंप्यूटर डजंट मीन कि वो लेस नंबर ऑफ इंस्ट्रक्शन यूज करता है. फॉर एग्जांपल इंटेल में कितने इंस्ट्रक्शन सेट है? इंटेल का 8051 जो है 112 113 ऐसे कुछ है, 79 से ज्यादा है, इंक्लूडिंग ऑल द इंस्ट्रक्शंस. इतने नंबर ऑफ इंस्ट्रक्शन सेट्स वो यूज करता है, विच आर यूजफुल फॉर इंटरेक्टिंग विद द, कम्युनिकेटिंग विद द मेमोरी. रैम रोम से कोड फेच करके लाएगा, और तो पूरा जो साइकिल है, मशीन साइकिल एग्जीक्यूट करता है. बट जो पिक लॉन्च हुआ, पिक में कितना है? ओनली 32 इंस्ट्रक्शन सेट्स. ठीक है, 32-34 इंस्ट्रक्शन है पिक में. सो इट इज नॉट दैट
Windows Phone. Android version but it's not.
IITs. Ours is an institution of national importance like IITs. Academically जो अक्सर है. So उसमें ये सब्जेक्ट हमारा एम्बेड सिस्टम का है तो हम थोड़ा ये डिटेल में थोड़ा कवर करते हैं इनका एडवांस लेवल पे. बिकॉज एकेडमी जो खुली है अक्सर it is open as a for imparting the higher learning education. It is not covering undergraduation. It is for higher learning. Therefore, we have to keep that level. So IIT at par we have that. Because main thing is research, and what they want is that we should transmit our research to the students. So our 90% thing is doing research, and 10% is what we have experience.
ये सारी कॉलेजेस है, ये उनका सेंटर है EDB2 ई परम ने ई RM ये नाम देता है अपना वहाँ से इंस्ट्रूमेंट चल रहा है। ये वाला टूल बॉक्स आया हुआ है, टूल बॉक्स का कुछ हो रेड वाले
He is also developing a complex embedded system.
ये बात आया यहाँ पे क्लिक
Hello, MMU Mulana.
यहाँ पे
Hello, MMU Mulana.
Yes, sir. Hello. Sir, we are facing problems in voice. You are not getting your voice properly.
Sir, but about now, अभी audible है sir?
Yeah, it's audible now.
Yes. So we may continue. We were explaining the difference between RISC and CISC architecture, and we explained that how RISC is simplified architecture and it serves the purpose. It is, I may not say that it is more better than CISC, but it is at par with the CISC. And depending upon the application to be developed, any industrial application to be developed, we have to take a decision in terms of whether to be employed CISC-based controller or RISC-based controller or a combination of both. So time, you know, as I said that it actually takes into consideration how many number of cycles it takes, the time required for execution of one instruction, and number of instructions required per program. So you can see here the RISC is optimizing the number of cycles taken per instruction. What RISC is doing, it is optimizing that reduced instructions, and they are taking less number of cycles. As I said, one cycle, one machine cycle instruction hai, 1 byte instruction hai. So it is optimizing upon the cycles taken by the instruction. Whereas CISC kya karta hai, it is focusing upon its philosophy is using less number of instructions per program. So this is the CISC philosophy. RISC philosophy is using less number of cycles per instruction, and you know, altogether it is actually multiplication of time taken per cycle. So therefore, if you, although you might be using less number of instruction, but if the number of cycles taken are more, then the total time taken by the program is more, and that is how you can define the efficiency and productivity of the embedded system. So you will have to have this understanding of what kind of controller that you are employing and what kind of instruction set it is possessing. So definitely it matters what kind of application you will be getting into, what kind of industrial application you will be developing. And instruction pipelining is another concept which again results and benefit in terms of developing higher productivity embedded system. What happens, you know, in pipelining is a fetching, decoding, and execution. I'm covering it up very fastly without explaining everything in details, but this is one of the important consideration and concept, that is pipelining. What happens in pipelining is that the instructions are getting executed in parallel. By the time that first instruction is getting fetched and decoded, the second instruction is getting fetched. And by the time the first instruction is reaching to the execution state, fetching, decoding, and execution, the third instruction is getting fetched and the second instruction is getting decoded. So that is what is the pipelining is, and this again helps into the efficiency increase. So any normal which executes the thing machine cycle sequentially may take 9 cycles. This is actually not 15, but it is 9. And then if it is the pipelining architecture, you can see that it takes only 3 or 5 cycles. That is the biggest difference for the same instructions. So important design decisions may be which one to use, CISC or RISC, microprocessor or microcontroller. So the answer to this is microcontrollers are used when the program is small, less complex instructions, and they are located in the internal memory. And microprocessors will be using if the program is large number of computations are involved and have to be carried out. CISC will be used when intensive computations are required. So okay, this is how, and there are a number of this, so we'll not get into this now. I wish to switch over to something now, real world thing. So in real world application, we were seeing that there are, so this was all the background that what should be the important consideration while you think of developing real world industrial application. So real world applications or industrial applications, and we have seen that how the design consideration are to be made, what are the types of classifications, what is the embedded system, and what are the constraints. So what is all important in terms of developing. Now there are few more important things. What is microcontroller? We have already seen. I think I don't have to. But there is one just question, just to keep you awake. Can you tell me that why all blocks? I have shown you one block diagram wherein that memory, processor, peripheral, they were connected through 3 buses. Can you tell me that what is the driving force? What is the motivation of connecting all these blocks to a 3 common buses? जो 3 common buses होते हैं, एड्रेस बस, डेटा बस एंड कंट्रोल बस, इसके साथ क्यों ऐसे कनेक्टेड होते हैं? व्हाट इज द मेन ड्राइविंग फोर्स? व्हाट इज द मेन बेनिफिट? क्या मोटिवेशन है that we connect the blocks of any controller or processor to a 3 bus system? क्यों करते हैं ऐसा? रैम के लिए चाहिए हमें, रोम के लिए भी चाहिए 3 बस, और सीपीयू को भी चाहिए, और पेरिफेरल को भी चाहिए. तो ये 3 बस सिस्टम ऐसे क्यों कनेक्ट करते हैं? जिस तरह से मैंने दिखाए थे, दैट वाज अ कॉमन बस सिस्टम. कॉमन बसेस क्यों यूज करते हैं? यस, एनीबॉडी फ्रॉम बीट पॉलिटेक्निक? कॉमन बसेस, 3 common buses क्यों यूज करते हैं कनेक्शन के लिए?
Sir, any system has to process. There are basically 2 process has to be done. One is data and other is opcode.
नहीं, वो पता है. सॉरी, मैं पूछ रहा हूँ ऐसे क्यों करते हैं? 3 common buses क्यों है?
Sir, any process requires data, instruction, opcode and control signals for performing.
सर, वो ठीक है, मैं कह रहा हूँ कॉमन बसेस क्यों है?
Sir, because they are all dedicated buses.
हाँ, ऐसे क्यों है? वाई? चलो मेरठ बता सकते हैं, मेरठ वाले, या इफ नॉट फ्रॉम मेरठ, जयपुर. जितनी टिक किए उतनी है ना? जयपुर. ये 3 common bus system क्यों होता है? Why all these blocks are connected, attached to 3 common buses? जयपुर. अच्छा, मौलाना वाले, am I audible to you, Maulana?
Yes, sir, you are audible to us.
Thank you. Can you respond to my question? Why we attach these blocks of processor or controller with the 3 common buses?
Sir, maybe it is for synchronization.
Chalo, anyways, I will answer the question. You don't have to give much.
Hello.
So the answer is very simple. There are 2 questions underlying. One is microprocessor pins are kept down. Why do we use this kind of architecture? See, just imagine if it is required to the RAM. If you are providing 3 bus to the RAM, 3 bus to the ROM, and 3 bus to the microprocessor, and 3 buses to the peripherals, कितने सारे चाहिए होंगे आपको? So it would have resulted into increasing the number of pins required. Number one. Secondly, if you are thinking of any scalability, expansion, you want to interpret something else, more memory or more peripherals, then it is, again, yes. So it can be easily expandable. So it is a memory map system. So these are the main motivations for having this kind of common buses. And obviously we all know everything needs data and control, and therefore that was all known to us. ये हमने देख लिया था. देखिए, नीड इज द मदर ऑफ इन्वेंशन. तो जितने भी रियल वर्ल्ड इंडस्ट्रियल एप्लीकेशंस है, उनका क्या था कि देखो पिक क्यों आया. पहले तो इंटेल था, एंड वेरी स्मार्टली इंटेल ने क्या किया, अपना जो बेसिक कोर था MCS 51 इंडस्ट्रियल कंपैटिबल C51 स्टैंडर्ड जो है, विच इज 8-bit इंटेल स्टैंडर्ड, विच इज कॉमन टू ऑल, वो उन्होंने वाइजली सबको डिस्ट्रीब्यूट कर फ्री ऑफ कॉस्ट. कोई इंटेलेक्चुअल प्रॉपर्टी नहीं मांगा. दे वाइजली डिस्ट्रीब्यूटेड बिकॉज दे वांट टू get it popularized and let it follow the same standard. लेकिन फिर भी why there is a difference and why there is advancement, why Atmel existed, why Silicon Labs existed, why Philips came into existence, why PIC came into existence, ये क्यों आया सब? And you see, when they came up with something addition. something new, and it did not happen just like that. For everything there is a motivation and there is a driving force. So we call it need. Need is the mother of invention. Need is only the mother of invention, I would say, right? So देखिए कुछ भी होता है तो हमारे लिए कुछ जरूरत होती तभी हम करते हैं, अदरवाइज हम नहीं करते. सो जैसे एटमेल आया, सबसे पहले हम जब करते थे इंटेल के साथ काम करते थे तो हमें एक्सटर्नली मेमोरी लगानी पड़ती थी, रैम लगानी पड़ती थी, रॉम लगानी पड़ती थी, स्पीड कम होता था. एक मेमोरी 270 की पहले प्रोग्राम करनी पड़ती थी, उसके ऊपर एक विंडो बना होता था यूवी इरेजेबल, उसके ऊपर अंदर रखना पड़ता था. अगर प्रोग्राम गलत हो गया उसको इरेज करो, इट यूज टू टेक 20-30 मिनट्स एंड इट यूज टू वेस्ट अवर लॉट ऑफ टाइम. जो कंप्लीट प्रोग्राम एम्बेडेड डेवलपमेंट साइकिल था वो प्रोडक्टिव नहीं था पहले, एंड मोर और कॉस्ट इफेक्टिव भी नहीं था. सो प्रोडक्टिविटी भी नहीं थी, कॉस्ट एफिशिएंसी भी नहीं थी. एक मेमोरी यूज टू कॉस्ट 1000 रुपीज 2000 रुपीज, तो हम एक से ज्यादा, दो से ज्यादा नहीं रख पाते थे. कि एक आपका प्रोग्राम खराब हो गया, उसको इरेज करने के लिए रख दिया, नेक्स्ट में प्रोग्राम किया, फिर से कोड को टेस्ट किया, हार्डवेयर को टेस्ट किया, एंड जस्ट सीइंग दैट वेदर इट इज वर्किंग एज रिक्वायर्ड. सो तो ये सब तकलीफें थी. सो दीज वर ऑल हैसल्स, दीज वर ऑल प्रॉब्लम्स. So Atmel thought, why not to, and then advancement also kept happening in the memory and all that. So Atmel thought, why not to do something and do a electrically erasable memory. So they employed, advancement happened into memory, and they used that memory, electrically erasable memory, into the microcontroller. They integrated inside it. So inbuilt. So Atmel की अगर आप chip 89C51 रेफर करते हो, do you know what is the significance of 89C51? What do you understand by 89? देखो 89 जो Atmel, AT89 जो है, जो हम लिखते हैं AT, that stands for Atmel. 89C51. तो 89 क्यों है, 80 क्यों नहीं है? There is a meaning to it. 80 का मीनिंग कुछ और है, 89 का मीनिंग कुछ और है. But they are all C51 standard. Do you know क्या है anybody? 89 is not a year. So you will say 80 is a year. ये जो बना है, देखो नॉर्मली जो भी प्रोटोकॉल्स होते हैं, इंडस्ट्री स्टैंडर्ड्स होते हैं, दे आर स्टैंडर्ड. RS-232 तो सब जगह RS-232 ही रेफर होगा, इसका मीनिंग हर जगह एक ही रहता है, ऐसे बदलेगा नहीं. जो इंटरनेशनल एजेंसी है उसकी, इलेक्ट्रॉनिक एजेंसी, स्टैंडर्ड्स एजेंसी, उन्होंने RS-232 बनाया. तो 89 जो है, सो विल नॉट नाउ वेस्ट मच ऑफ द टाइम by queries. I'll try to wind up. 89 का मीनिंग होता है फ्लैश मेमोरी, जिसके अंदर फ्लैश मेमोरी है. सो जहां भी आप 89 देखोगे, चाहे वो एटमेल ने बनाया है या फिलिप्स ने बनाया है, दे ऑल मीनिंग सेम, दैट इज फ्लैश कंट्रोलर. ठीक है. 80 जो है उसके अंदर इनबिल्ट फ्लैश मेमोरी नहीं है. ठीक है. सो 89 फ्लैश मेमोरी. तो एटमेल जो आया, तो एटमेल की ये जो रिक्वायरमेंट में बता रहा था कि पीपल वर फेसिंग अ प्रॉब्लम कि ये सब इतना सारा टाइम जो वेस्ट हो रहा है, डेवलपमेंट साइकिल फास्ट नहीं था. एंड दिस डेज यू नो यू वांट टू हैव प्रोडक्ट लॉन्चिंग वेरी फास्ट. आज टाटा ने लॉन्च किया कार, तो दूसरे दिन हुंडई लॉन्च करता है, तीसरे दिन होंडा लॉन्च करता है ना. मोबाइल आज एक माइक्रोमैक्स ने लॉन्च किया, कल एप्पल लॉन्च करता है, सैमसंग लॉन्च करता है, मियोमी लॉन्च करता है, कौन से और काफी सारे Xiaomi वगैरह. So there are so many every day. I mean there is a competition, and competition is अगर आपका development cycle late है, it is not very efficient, so you cannot compete in the industry. So therefore ये सब आपको टेक्नोलॉजी उसी तरह की यूज करनी पड़ेगी. तो जब भी आप रियल वर्ल्ड इंडस्ट्रियल एप्लीकेशन डेवलप करोगे तो आपको ये सब कंसिडरेशंस ध्यान में रखनी पड़ेगी. कौन सा कंट्रोलर यूज कर रहे हो, कौन सा लेवल का सिस्टम डेवलप कर रहे हो. ठीक है. सो एडवांसमेंट्स जो है वो एटमेल में इस तरह से हुई. सिमिलर इज द, सो देयर इज अ हिस्ट्री एंड स्टोरी टू ईच कंपनी. उसके बाद में फिलिप्स ने क्यों किया. ठीक है. फिलिप्स का भी स्टोरी है. उसने सोचा कि उसकी भी एक कहानी है कि जैसे ये कर रहा था, फ्लैश मेमोरी था, हम इरेज करते थे, इलेक्ट्रिकली इरेजेबल था वो. ठीक है. प्रोग्रामर में रखा, इलेक्ट्रिकली इरेज किया, एंड देन यू आर गेटिंग नेक्स्ट प्रोग्राम प्रोग्राम्ड इनटू इट. वो नहीं चला क्योंकि बिकॉज विद इन फ्यू सेकंड्स, माइक्रो सेकंड्स में वो जो है इलेक्ट्रिकली इरेजेबल इरेज हो जाता है. बट क्या था, आप लेते थे और फिर सर्किट में उसको डालते थे, फिर से टेस्ट करते थे, नहीं चला, फिर से निकालते थे सर्किट से, डालते थे, फिर से करते थे. अब इरेज का प्रॉब्लम तो सॉल्व हो गया. ठीक है. लेकिन क्या है कि जब वो निकालते थे, बहुत से बार हमें पता है उसकी जो लेग्स है वो टूट जाती थी निकालने डालने में, और सॉकेट भी लूज हो जाता था. एंड समटाइम्स ऐसे होता था कि हम प्रोग्राम को देखते रहते थे और पता चला उसका पिन ढीला है, देयर इज अ लूज कनेक्शन, सो इट इज नॉट मेकिंग गुड कनेक्शन. सो ये सब इश्यूज थे. देन फिलिप्स की फिर कहानी आ गई. फिलिप्स रिकॉग्नाइज्ड इट. ठीक है, फिलिप्स ने क्या किया कि हम जो है उसने उसके अंदर डाल दिया बूट वेक्टर डाल दिया, एक बूट वेक्टर डाल दिया. उसके थ्रू उन्होंने क्या किया, इन सिस्टम प्रोग्रामिंग का कंसेप्ट डाल दिया. सो इन सिस्टम प्रोग्रामिंग विदाउट रिमूविंग द chip, you can program it through your environment, integrated development environment, it is getting programmed. So that, and of course it reduce your time. So आपने यहाँ चेंज किया, देखा एलईडी का प्रोग्राम चल रहा है नहीं चल रहा है, फिर से चेंजेस किए, मॉडिफिकेशन किए, चल रहा है नहीं चल रहा है, लाइक दैट. यू डोंट हैव टू रिमूव. देन इन एप्लीकेशन प्रोग्रामिंग भी डाला. इन एप्लीकेशन ये है कि आपको जो है एप्लीकेशन कुछ रियल टाइम में लगा हुआ है, आपके मॉडर्न्स लगे, कुछ लगे, आपको ये नहीं कि भाई जैसे होता है ना कि मुझे इलेक्ट्रिक में कोई फॉल्ट आ गया, पावर में फॉल्ट आ गया है, तो वो ठीक करने के लिए पहले पावर ऑफ करना पड़ता है, सब लोगों को इनकन्वीनियंस करना पड़ता है, और फिर पावर का ठीक करूंगा, फिर वो ऑन करूंगा. सो इन एप्लीकेशन प्रोग्रामिंग इज समथिंग जहां पर आप जो रियल वर्ल्ड एप्लीकेशन है उसको बिना इंटरप्ट किए हुए चीजों में चेंजेस करोगे, प्रोग्राम में चेंजेस करोगे, एंड यू विल गेट देम इफेक्टेड. सो दैट इज इन एप्लीकेशन प्रोग्रामिंग. तो एनालॉग डिवाइसेस की भी ऐसी कुछ कहानी है, सिलिकॉन लैब्स की भी ऐसी कहानी है. सो आई विल नॉट गेट इनटू ऑल द स्टोरीज और विल कट इट शॉर्ट हियर. सो देयर आर एडवांसमेंट्स, ये हमने देख लिया है. ये ब्रेन टू द एम्बेड सिस्टम माइक्रो कंट्रोलर होता है. देन कोई भी इंडस्ट्रियल एप्लीकेशन डेवलप करने के लिए व्हाट आर द फैक्टर्स शेपिंग द परफॉर्मेंस. सो सिलेक्शन ऑफ कंट्रोलर मैटर्स. तो इस सिलेक्शन का भी मैं डिटेल में नहीं बताऊंगा, वी हैव टाइम कंस्ट्रेंट, कि कैसे सिलेक्शन ऑफ राइट माइक्रो कंट्रोलर आर्किटेक्चर जरूरी है. एनी कंट्रोलर आपको कुछ बोला कि ये डिजाइन करो, इस रूम का जो है एनवायरनमेंट कंट्रोल करो, तो आप कोई भी कंट्रोल थोड़ी लगा सकते हो. यू हैव टू मेक ए राइट सिलेक्शन. उसके लिए पूरा एक जस्टिफिकेशन, एक डिजाइन थ्योरी है. सो दैट इज व्हाट इज रिटन हियर. मैं उसकी डिटेल में अभी नहीं जाऊंगा. उसमें पहला फैक्टर है शेपिंग द परफॉर्मेंस ऑफ माइक्रो कंट्रोलर, पावर कंजम्पशन. आई नो आप लोग तो इंटरेस्टेड होंगे ये सब जानने के लिए, बट वी डोंट हैव टाइम, सो विल स्टिक टू द टाइम. इसमें फिर पावर कंजम्पशन, कॉस्ट, टूल अवेलेबिलिटी, रेपुटेशन ऑफ द कंपनी, एप्लीकेशन. तो यहाँ सब कीवर्ड लिखे हुए हैं. आई विल डिस्प्ले यू माय कॉन्टैक्ट डिटेल्स. लेटर ऑन यू कैन कॉन्टैक्ट मी एनी टाइम इन सब एस्पेक्ट्स के ऊपर गाइडेंस के लिए. आई विल बी हैप्पी टू एक्सटेंड माय ऑल guidance to anyone who needs it, but now I will not cover every point in details and we will move forward. और efficient design consideration में थोड़ा सा टच कर देता हूँ, उसके बाद में I will show you the actual real world application. efficient design consideration में क्या है, आपको हार्डवेयर की डिजाइन कंसिडरेशन ध्यान में लेने हैं और सॉफ्टवेयर के लेने हैं. ठीक है, तो हार्डवेयर में जैसे वोल्टेजेस, इसके भी मैं पॉइंट सिर्फ रीड करता हूँ, आपको डिटेलिंग नहीं एक्सप्लेन करूंगा. हार्डवेयर में आपको फीवेस वोल्टेजेस वाला हार्डवेयर डेवलप करना है, कंजर्व करना है पावर को, और स्मार्ट चॉइसेस करनी है, शटडाउन व्हेन नॉट नीडेड, अवेलेबिलिटी, टेम्परेचर स्टेबिलिटी, डेवलप टू द इवेंचुअल फॉर्म. देयर आर मेनी पॉइंट्स व्हिच यू मे नॉट बी अंडरस्टैंडिंग, बट आई एम नॉट एक्सप्लेनिंग इट नाउ, क्योंकि मुझे एक आपको रियल वर्ल्ड एप्लीकेशन दिखा देनी है इसके बाद में. फीवेस बोर्ड्स यूज करने हैं, सॉफ्टवेयर में आपको इजी टू रीड फंक्शंस करने हैं, रियल टाइम इंटरफेसिंग, ये सब एक्चुअली कंसिडरेशंस है. सो डिफरेंट डिटेल पेरिस से करने पड़ेंगे. अब इसमें हम एक एप्लीकेशन आपको दिखाएंगे कि एक रियल वर्ल्ड एप्लीकेशन प्रिसीजन फार्मिंग का. तो दिस इज प्रिसीजन फार्मिंग क्या है कि हमें देयर आर टू एरियाज ऑफ एग्रीकल्चर बेसिकली, प्री हार्वेस्टिंग एंड पोस्ट हार्वेस्टिंग. सो बेसिकली एक इसका मैं आपको, लेट मी स्टार्ट समथिंग लाइक दिस. हियर आई विल शो यू वन अनदर इम्पोर्टेंट एस्पेक्ट. This is the background of it. The biggest challenge that we have in this century is how to feed 9 billion people, which are expected to grow by 2050, in a manner that will advance ecological development and reduce the pressure on the environment. So you have to produce a good food, required amount of food adequately for these 9 billion people by 2050, without actually impacting the ecology. So देयर आर 2-3 फैक्टर्स टू इट. आपकी सस्टेनेबिलिटी को आपको ध्यान में रखना है. पीपल विल नीड न्यूट्रिशियस फूड, planet will have to conserve the energy without actually damaging the planet, and profit is without impacting the, it should basically profitably produce all this agriculture. So therefore अच्छा, national food facts काफी ज़्यादा disturbing है. lot of people are going hungry, undernourished है, degradation of land है. इंडिया का भी काफी नेशनल लेवल का स्टेटस भी बहुत बुरा है. सुसाइड्स हो रहे फार्मर के, अराउंड 3 lakhs farmers have already done suicides. Environmental status is also not very rosy. और फिर हमारी जो हाई यील्डिंग वेराइटीज है वो भी बहुत अंडर परफॉर्म कर रही है. कल्टीवेशन का भी बड़ा, सो देयर इज अ फूड क्राइसिस. ठीक है. देन देयर आर पीपल हु आर गोइंग टू स्कूल विदाउट टेकिंग फूड, होल डे दे डोंट टेक फूड. तो इंडिया इज ऑन सेकेंड नंबर टू दिस. एग्रीकल्चर प्रोडक्शन हमारा बहुत डाउन हो गया है एंड इट इज अ फैक्टर ऑफ वरी. सो इसीलिए ये प्रिसीजन एग्रीकल्चर का एक कंसेप्ट है जिसको मैं थोड़ा सा आपको बता देता हूँ और एक वीडियो दिखा देता हूँ. इसमें व्हाट इज रिक्वायर्ड, व्हाई इट इज हैपनिंग, दैट वी नीड टू नाउ अप्लाई ऑप्टिमल इनपुट्स टू द एग्रीकल्चर लैंड so that it is producing the higher productivity and without damaging the yields and without damaging the environment also, and also at the same time it should be a profitable. So ये एक हमने टेक्नोलॉजी बनाया. दिस इज अ ट्रैक्टर माउंटेड मैपर. ये क्या करता है कि
हौली हौली नीचे करे. नहीं रेस उसका कोई चक्कर नहीं, बस आपको स्लो रखना है. रेस स्लो रखिए.
वॉल्यूम बंद कर दो. So let us actually this what it does is actually it is scanning the surface of the soil and it is mapping the whole nutrient characteristics of the field, and it is letting the farmer know that what is required to be applied to the field and how much it should be applied. The main principle of this precision agriculture is how much amount of nutrient should be applied, in what amount, what type of nutrient should be applied, where it should be applied, at what location. So it will guide to the farmer or agronomist for that matter that how much it should be applied, where it should be applied. So it is a complete agronomic guidance. So in this technology we have deployed PIC microcontroller 32-bit. It was 16-bit. Now we have migrated to the 32-bit. There is a graphical user interface. This LCD has been also replaced with the bigger human machine interface, touch panel based, wherein they get directly the maps of the land, how the land characteristics is changing, and there is a GPS to it, geographical coordinates, which tells that what is the information and where it is. So location of the information in the field. So based upon these maps, let's say the next step to this is a variable rate application. So these maps, they get loaded to the sub piggyback kind of arrangement, wherein the farmers, farmer just spray करते हैं, pesticide spray करते हैं, anything nutrient supply करते हैं. ऐसे कोई piggyback रहेगा टेक्नोलॉजी टाइप, और जिसके अंदर ये मैप जाएगा और वो वेरिएबली डिपेंडिंग अपॉन उस मैप के इनपुट के बेसिस पे क्या चीज कहाँ पर अप्लाई करनी है वैसे वैसे वो अप्लाई करेगा. So everywhere there is intelligence and embedded system designed to it, which actually interprets everything. So this technology was successfully tested at Punjab Agriculture University, and the beauty of this technology is it can scan the soil surfaces just by touching the surface below 3 feet. 1 मीटर नीचे तक का जो सॉइल सरफेस है उसके नीचे तक की कैरेक्टरिस्टिक्स को बताता है. बिकॉज प्लांट्स के लिए ये नहीं कि ऊपर की क्या है लेवल और क्या टाइप है उसका न्यूट्रिएंट लेवल क्या है और सॉइल का क्या स्ट्रक्चर है. इट मैटर्स की रूटिंग जोन 15 सेंटीमीटर 30 सेंटीमीटर, डिफरेंट क्रॉप के डिफरेंट रूटिंग जोन्स होते हैं, प्रोडक्टिविटी रूटिंग जोन्स. तो बिना टच, बस ऊपर टच करते हुए 1 इंच टच करते हुए नीचे का पूरा कैरेक्टरिस्टिक्स को बताता है. सो दिस इज द लेटेस्ट टेक्नोलॉजी दैट वी डेवलप, और हमने इसका पेटेंट भी फाइल किया है. एंड दिस इज ओनली द टेक्नोलॉजी आफ्टर यूएसए जो हमने भी इसको बनाया है. I think there is a company called Veris Technology in USA who developed it first, and we were the second to develop this. तो आपको जस्ट एक मैप दिखाता हूँ कि बाकी काफ़ी चीज़ें हैं कि कैसे करता है काम, और इस तरह का मैप ये जनरेट करता है which tells you, informs you about complete soil characteristics, how it works. So that is what all I think I have to inform you, and this is how the whole architecture of it, block diagram of it, and there are a number of more applications which we would have shared, but looking at all the time availability, I have shared one of the important applications. So this is the smart farming concept. So wherein all this happens, it can produce this kind of digital maps to guide the farmers कि pH कैसा है, आपका nutrient level कैसा है, and different layers से हम जैसे कर सकते हैं ऐसे. So I think I will stop there, and I said there are a number of more applications, but I'll finish and hand it over to the madam. And यहाँ पर मैं अपनी thank you की slide ढूंढ रहा हूँ actually.
That I do.
So okay, I'm fine with my contact details. We have many number of other applications that we develop. So anything you wish, we can interact, and thank you for patiently listening.
Thank you so much, Dr. Bansal, for sparing your valuable time and experiences and sharing your experiences with us and our participants. I hope all of you have benefited from the rich experience of Dr. Bansal. And in case you have any queries, in case in future you want to have any kind of collaboration with him, he's given his contact details with you. Now we have our next expert also with us waiting, and we'll break for 10 minutes for the tea break. And we'll again assemble here after 10 minutes. So please, all of you, be here at 12.
And yes, one information that any student who would like to participate with us in R&D are welcome. You can conduct your MTech dissertations or doctoral studies at CSIO. We have university as well as research labs. So it is open to you for conducting your research. So you can contact me on that matter.
Thank you, sir.
Hello. आता कोण आहे
Hello. 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 Hello.
Yes, sir.
Hello. Hello.
अजून एक खास सेक्शन आहे युनिव्हर्सिटी ॲप्लिकेशन मायक्रोकंट्रोलर थांबा जास्त थांबा माणूस बदलेल फक्त कंटेंट बदलतील कसं बाहेर फिरलं लक्ष
क्लासेस लगा दी मैंने।
ये माइक पे फंक्शनल है नहीं? ओके
शुरू कर लो। Very good afternoon to all of you. Now we have with us our next expert, Mr. Sandeep Singhai, who is working as senior scientist in Central Scientific Instruments Organization, Chandigarh. He is working in defense electronics domain and is a member of the only team in the country who is working on head-up display system. And today he will be sharing with us his experiences and his main research domain in the head-up display. So I hope all of you will benefit from his vast experience and rich experience in the field of head-up display. Over to you, sir.
So good afternoon everybody. Well, all the centers are connected. Are you audible to me? Can we interact? So, should I start? Have an affirmative tone from all the centers? Should I start? So, today I will talk about basically our research domain. We are working at CSIO in the defense electronics domain. And basically we develop some display systems for the Army and Air Force. And our main product is head-up display. Before starting, I would try to be short and sweet because I am the one which is between you and your lunch. So it's always difficult to have a session which is just before lunch because everybody seeing the watch and all those things happen. Normally it do, but still I will try to keep things interesting contain your interest, and at the same time I will discuss briefly about what my actually work is. So basically we have developed an head-up display system for LCA Tejas. We are working on head-up display system for HJT Sitara, and as well as we are in the process of getting head-up display system development project for various other LCA Mark II Navy and all those type of aircrafts. So the brief outline of my talk would be development of head-up display system for strategic applications. Basically, we are into strategic domain. So what are the nitty-gritties of development in the strategic sector? What all agencies are involved? I will talk a brief about. Since we have just 1 hour, so I will be skipping certain topics, and if you feel the need of them, you can stop me and we will discuss. Then what is the need of head-up display, its composition, challenges and features. Within the head-up display, basically there are one control system, which is basically a health monitoring system, which continuously monitors the health of the head-up display, because head-up display is one of the 256 LRUs which are in the cockpit of the LCA aircraft. So each and every LRU, line replaceable unit, should be so that in case of any default or any problem with that particular LRU, it should manage on its own without causing any catastrophic damage to the entire aircraft. So there is one built-in test equipment. It's a microcontroller based system which is in alignment with the overall objective of this course. And then we have a electronic standby site. Basically whatever head-up display displays, which I will discuss in due course, is given to it by the main computer, which we call the mission computer of the aircraft. The mission computer collects that data from various sensors which are associated or attached with the aircraft, and give that information to the head-up display in the form of an image. Basically, if we talk in terms of signal, that is XYZ signals. So in case those XYZ signals are not available, HUD would go blank. HUD does not have any information to show. So for those cases, standby displays are required, and they are basically of two types. One are static, which are optical solutions. Other are dynamic, which are basically electronic solutions. So that is one such display system, electronic standby site, which I will discuss. And if we have time, we will also discuss the utility of HUD in other sectors, basically civil aviation. It's a mandatory feature in defense aviation, but it is an optional feature in civil aviation, as well as you can think of its application in railways and high-end cars. They do have head-up displays right now. So first of all, when I need to develop something for the strategy sector, what are the basic requirements? In the last session, you heard that all those fancy controllers and state-of-art application. In defense, robustness, ruggedization, these are the primary parameters, because your product has to work not only in Leh Ladakh but also in Suratgarh. So the temperature range is quite vast. The aircraft can fly at 200 feet to 50,000 feet. That is also a vast range. Now if you are talking about the pressure height differential, it converts into pressure differential. So it should also work in various pressure conditions. Besides that, there are a lot of other environmental conditions plus EMI EMC conditions. Are you aware about EMI EMC problems? Electromagnetic interference and electromagnetic compatibility issues. Every device in which have a moving electric part have a magnetism induced. So within the cockpit there are around 256 LRUs. Some might not be electrically conductive, but most of them are. Each and every device generates certain amount of EMI. It's for sure that every device will generate certain EMI. Now, two devices does not cause interference to each other. Two conditions must be met. First, your device should be electromagnetically compatible with the total gross limit of EMI which is being generated, number one. And number two, to maintain that gross limit, the emission of EMI from your device should be within the acceptable limit. So there are certain tests and all those things which are mill standard tests which we perform, and we ensure that our device is also EMI/EMC compatible. So these are the various agencies as far as head-up display for Tejas aircraft is concerned. There is one agency, Aeronautical Development Agency in Bangalore, which is basically a special purpose vehicle of DRDO, which is the primary funding agency for the Tejas aircraft. Then we have CSIO, which is the design agency for head-up display. Then there are two types of test agencies which are involved with you whenever you design something for the defense sector. One is CEMILEC, Center for Military Airworthiness and Certification, through its regional centers, which we call RCMAs, Regional Center for Military Airworthiness. We have one in Chandigarh and 3 BRD Air Force. So these are basically involved at the white box level, at the design level. Whatever design I make, whatever design I propose, whatever design change I propose, I should get it certified from the RCMA inspectors. And whatever testing I perform, they are there with me to certify that the test has been done in accordance with the various requirements. Then there is another agency of Government of India called DGAQA, Director General Aeronautical Quality Assurance. These are basically quality people. So they are involved with you at the black box level. They are not concerned with what the design you have. They are concerned with the required input and the solicited output. That should be in order. So they are the quality inspectors which also come in once production starts. Then in our case, we are basically design agency. The production of HUD is being done by, in case of head-up display for Tejas, Bharat Electronics Panchkula. They are our production partners. In a way, this teamwork has resulted, and this head-up display single LRU cost around 60 to 70 lakhs. And its indigenization, it is one of the main LRU of Tejas which has been indigenized. Besides avionics and materials and all other things, it is one of the main LRU which is placed at the center in the cockpit. Visually I will show you, but this is the entire gamut or various players which are involved in the development of head-up display. Now this I would like to skip, basically project sanction. Then there are various stages: preliminary design review, then we have critical design review, then we have the form fit functional unit, wherein our main objective is to have the required form, shape and size and the required output. We don't stress on its robustness much in that unit. Then we develop the SOF unit, safety of flight unit. By all means, it is the most rugged unit. It has to undergo all the environmental tests as per MIL at 810E and all the EMI/EMC compatibility tests as per 461 on 462 MIL standards. Once this is done, we get, up till now, we are not allowed to fly that unit. SOF unit can't fly. SOF unit can only be tested for ruggedness and robustness. Once that is cleared, then we develop what we call airworthy units. Airworthy units are those units which are given flight clearance by the RCMA and they are allowed for test flights. Then the next stage is LSP, limited series production. That is basically just a stage prior to the series production, and finally the unit goes into production. These are the various stages in case of any defense development. Now what is head-up display? In simple words, if I tell you that instead of displaying the speed of your car onto the odometer which is available at the front panel, and for which if you want to look into, you have to change your line of sight. Yes, for looking into your speedometer you need to change your line of sight. When you are looking into speedometer, you are not looking the outside world. Instead, so that is a sort of head down display. You are changing your line of sight. If I show that information, that critical information on your windshield in a manner that it does not disturb you or disturb your outside world vision, then that device is, in simple words, called head-up display. So basically head-up display displays flight information in a collimated form. Collimated means parallel beams. Collimated form, so that it is focused onto infinity. The reason is that if it is not collimated, if I place my hand just before my eye, it is disturbing the way I am seeing. But if I place this hand or the image of this hand at the background or at infinity, it won't disturb me much. So collimated form, so that the pilot can view this information superimposed on his view of the outside world. वो बाहर की दुनिया को भी देखता रहे, साथ में बिना डिस्टरबेंस के वो जो क्रिटिकल इंफॉर्मेशन है वो भी सुपरइम्पोज्ड फॉर्म में देख सके. This is the basic idea of head-up display. It is an essential line replaceable unit, LRU, of combat aircrafts, aiding the pilots for taking split-second decisions. These are various photographs. This image you can see in the bottom is basically the first image of CSIO head-up display, and then this is the head-up display for HJT-36 aircraft. It is putted in the cockpit, and then it's one such air show where our president, honorable president, is visiting our stall. So before going into what actually head-up display does is, I have detailed out some basic conventions of an aircraft movement. There are basically three axes, X, Y and Z, and the movement along each axis is called roll, pitch and yaw. Along the central x-axis it's roll, along the y-axis it's pitch, and along the z-axis it's yaw, like this movement. Okay, and to control these movements there are actuators in the aircraft which we call ailerons, rudder for yaw, ailerons for, and then we have an elevator for pitch. Ailerons are for roll. So what HUD does is, it improves the situational awareness of the pilot. जो भी पायलट को क्रिटिकल इंफॉर्मेशन नीचे देखनी है और जब वो बिजी है, जब he is combating or he is taking off or he is touching down, that critical part of the information we can show onto the head-up display. It's basically a parallel device. You have all those information into other MFDs also, which we call collectively as head-down displays. This is a typical navigation page of head-up display, wherein we are showing those accelerations and flight path markers and all other things. An interesting image follows, which I will discuss in detail more. So why is actually HUD required? What is the need of HUD? So imagine, I will try to immerse you into imagination that a fighter pilot is combating. Now what all task he has to perform during that time? Number one, he has to fly the aircraft. Number two, he has to attack the enemies. Number three, he has to protect himself. Number four, he has to communicate with other fellow pilots which are friendly to him. Number five, he has to keep a tab on the fuel pressure and all other things. So it's such a hectic point, and that time you can't expect him to see into those head down displays. It is actually where HUD is helpful to the pilot. So flying and navigation, aiming and firing weapons, takeoff and landing. Takeoff में कैसे help करता है? मान लिया आपका pitch है. Whenever aircraft flies, it flies with a pitch angle. Suppose the pitch angle becomes greater than a critical angle. What will happen? There are chances that your tail may strike the airstrip. So in case of an head-up display, you can have a clear-cut warning on the screen which is in front of you, which won't allow you to miss that important critical parameter. Normally pilots do not forget, but accidents do happen. So basically to get you better understand what is the utility of head-up display, there is a picture. You have three types of airstrips. One is the flat airstrip, B is the upsloping airstrip, and C is the downsloping runway. One runway is flat, one is like this, and one is like this. Now whenever a pilot is approaching that particular airstrip, you can see there is one blue line and one red line. So basically the aircraft is gliding. It is neither accelerating nor deaccelerating. It is coming with a constant speed, and there is a projection which pilot basically anticipates that by that gliding angle he will reach the starting point or whatever required point of the airstrip and touch it down at that point. Now in case of a flat runway, it usually do happens that his approximation is more or less compatible with the ideal glide path. But in case of an upsloping runway, it do happens that the pilot tend to come down because वो ऊपर से देख रहा है और एंगल कोई 2 2.5 3 डिग्री 4 डिग्री का होगा, इससे ज्यादा तो नहीं होगा। ऊपर से उसको जो विजुअली उसकी जो अंडरस्टैंडिंग आती है, तो देयर आर चांसेस दैट वो थोड़ा नीचे आ जाएगा। जो उसका ग्लाइडिंग पाथ होगा, यू कैन सी द ब्लू लाइन इन द सेकंड केस, इट विल बी बिलो द आइडियल ग्लाइड स्कोप। एंड इन केस ऑफ ए डाउन स्लोपिंग रनवे, there are chances that he is higher than the ideal glide scope. Now this is the situation also in case of a narrow runway, and the second case is also a case of a broad runway. Now if this approximation goes wrong, if he is higher and he is unable to touch that particular requisite point, what can happen? He will land, he won't land at the required point. He might land advanced position, and if the runway on the either part or the last part is not free or not available or is on a hilltop, then the aircraft can go into the gorge. A typical example I will show you.
It was the breaking up of the plane as it
recently, some years ago, there was a Mangalore aircraft crash of Indian Airlines flight.
The survivors
That was
either thrown free or managed to climb out through gaps in the fuselage as it split apart and before the flames consumed it. There was a blast, perhaps a tire bursting as the plane landed, this man says. Within 5 seconds there was fire and smoke all over. We looked up and saw an opening and crawled through it, says this man. The flight from Dubai to Mangalore was full of Indian migrant workers and their families returning from jobs in the Gulf. More than 20 children were on board. The plane, a Boeing 737, was only 3 years old. The airport, though, has a reputation as a challenging one for pilots. Its runways are carved out of hilly jungle country and are sited on a tabletop plateau with cliff-like drop-offs. The plane appears to have skidded off the end of the runway as the pilot tried to regain control and plowed into the gorge beyond.
There are certain challenges when you approach an airport that's laid out the way this one is, and it's nothing unsafe, but you just have to really pay attention.
So in these situations, head-up display might be more helpful, as the pilot doesn't need to rely more on his approximation. Rather, he will have some visual information with the help of which he can approximate his position and distance to the touch point. He will have some radar information which will give him the actual distance. Then there are various symbols in head-up display. As you can see, there is one small circle at the center with 2 wings. This is basically the aircraft point. Then there is a horizontal line which we call natural horizon. Now whenever the aircraft is below this natural horizon line, it means that it is losing height, it is coming down. Then you have a on the left side, you have a less than equal to sign or a crocodile's mouth. That particular sign is representing the flight path acceleration. Now when the aircraft is gliding at when the aircraft is accelerating, that particular symbol would be higher than the aircraft symbol. When it is deaccelerating or it is reducing its speed, that symbol would be below the aircraft reference symbol. But at the time of ideal gliding, these 2 symbols will superimpose each other or will be parallel to each other. So instead of having pardon? This head-up display is flying in Tejas. Right now in HJT 36 Sitara, we are test flights are being undertaken, and LCA Mark II also flying. Navy we have recently got it. So this is how, in that case, ideal glide path is available. Plus, with the help of radar and other information, he can also ascertain his actual distance from the initial touch point. These I would skip basically that I was talking about the tail strike warning. If the pitch becomes greater than a particular angle, a warning of tail strike comes in. Now, basically, as required for this course, we will come on to the. I think you are more or less connected with what is the actual utility of this particular device. So basically, this device contains three parts. The blue represents the electronics block. There is a optical block, and then at the top there is a beam combiner assembly. What the electronics block does is, it's basically a CRT based system. These days CRTs are not much used, but in case of head-up display, the utility of CRT is due to its high brightness levels. We get around 3500 foot Lampert at the output, even after all those optical losses and all those things. So basically what aircraft gives me is, or what aircraft gives the head-up display is, it collects the information which is already available in the MFDs from the various sensors which are installed at the various locations in the aircraft. That sensory information, for example, attitude information comes in from AHRS, attitude and heading reference system. Temperature sensors are installed on the wings and all those things. So what aircraft collects those signals, and through a display processor, it converts into an image. An image is anyway an XYZ information. XY for position, Z for intensity. That XYZ information is transferred to the head-up display through a RS-422 communication system. Now, head-up display is basically a CRT based system. So whatever electronic block assembly is in head-up display is to meet the requirement of the CRT, which requires single-handed current input signals, and the aircraft is giving it double-handed RS-422 signals. So whatever we need to do is to cater the requirement of the CRT. Again, what CRT needs is, aircraft has 28 volt DC power supply, but CRT, you might have read, was it in your syllabus? CRT needs lot of voltages: 1600, 16,000 volt, 1500 volt, 800 volt, filament supply 6.3 volt, then video input plus minus 48 volts. Again we have TTL circuits and ICs, so we need 5 volts. These all power supplies are also required, but what we are getting at input is 28 volt DC. So there are two basic parts of electronics or electronic functionality. One is to convert those signals into what is required for the CRT. Again, in old days we had TVs in our house and they had pin cushioning issues. कभी ऐसा हो जाता था स्क्रीन, कभी टेढ़ा हो जाता था, वो पिन कुशनिंग को भी आपको कैटर करना है. So in this particular head-up display, at the output we have a 3-inch CRT which is coated with a P53 phosphor. P53 phosphor gives us a yellowish green light in 543 nanometer domain. Reason that yellowish green light is compatible with the NVG goggles, night vision goggles जो पायलट पहनता है रात में फ्लाई करने के लिए, वो उसमें उसको दिखने में प्रॉब्लम नहीं होता. तो at the output of that electronics block there is one CRT fitted, and what I am getting from the aircraft as input is differential XYZ information plus 28 volt power supply. So now you can imagine what all I have into this electronics. One is to cater the power requirement. So I have two power supplies out here. One low voltage power supply which generates me 5 volt and 12 volt and 6.3 volt, and then a high voltage power supply which generates 16,000 volt, 1500 volt and 800 volt required for the CRT. Then for signal conditioning, I have line driver ICs, I have pin cushion circuit, I have video circuit and all those things into the signal processing card. One more important criteria was that my device should not generate EMI beyond a limit and should be able to work in a particular EMI environment, which is basically the sum of allowed limits for all the LRUs. So there are EMI EMC filters which we have installed. For power conversions or low voltage power requirements, we don't use regulators, we use DC to DC converters for a better power quality. So in a way, within that electronics, I have all these things: a cathode ray tube, a high voltage power supply, a low voltage power supply, data entry panel, rear data entry panel in case of a trainer aircraft. In case of a fighter, required in a trainer, there are two pilots: the trainer at the back and trainee at the front. A signal processing card to convert those x plus, x minus, y minus into x, y, z. Okay. Automatic brightness control systems are also required. Basically, the symbology brightness जो है वो very basically normally हमें दिन में brightness ज़्यादा चाहिए, night में कम चाहिए. इसके अलावा we also have a brightness sensor installed at the top of the head, which also gauges what is the outside brightness, and within the ABC mode we have the priorities with an algorithm that we can adjust automatically also. तो पहले जब वो golden eye करके TVs आते थे, आपने शायद याद हो, which used to adjust its brightness according to the room brightness, कुछ वैसे ही. Then for phosphor protection we have the byte system, phosphor protection, and as well as there are other systems also. Then in case the mission computer fails to deliver the input signal, we need some inbuilt symbology so that the pilot is helped in landing. So for that case, a standby solution is required. We have incorporated a electronic standby site in this. The positive point is it is dynamic. Negative point is in case you have some problem with head-up display electronics itself, then it won't work naturally. For optical का positive point ये है कि वो हर position में काम करेगा. Then finally packaging. CRT basically मैंने आपको बता ही दिया. HVPS and LVPS, data entry we can escape, signal processing. So these were the various design challenges which were met in the development of head-up display. Constraint, size and weight. You have an envelope for the cockpit and you have to develop everything into that particular envelope. You can't go beyond that. There is ECL, there is nose clearance line, other parameters which you should adhere to. Then robustness. Another feature for mechanical engineers is that the cooling is fanless in this particular head-up display. We don't have any fan for cooling the entire, whatever heat is generated by the system, the entire body, the black body has fins with it. So the entire body acts as a sink for the heat which is being generated. Compliance to mil standards, two type of mil standards I have repeatedly told. Environmental requirements which include humidity, low temperature, high temperature, thermal shock, mechanical vibrations, sine vibrations, random vibrations, and so on. And EMI EMC requirements. EMI EMC requirements for conductivity as well as with the touch. High brightness symbology. This is basically the USP of CSI ORD. In Sitara, we are going to replace the head-up display of Smith Aerospace, which is basically a subsidiary of GE. So the problem with that HUD is that the required brightness is not being achieved. It has a lower level of brightness, but CSI HUD is twice more bright than the Smith HUD. Wide field of view. Field of view is basically how much the pilot can see through head-up display. So basically in our case we give a total field of view of 25 degree and instantaneous field of view of around 20 degree. Sun glare is another problem which happens with head-up displays, that when sun is at the perpendicular, so it might be the case that the entire sun rays might enter the optics of the head-up display, thereby creating a complete glare type of a situation, and pilot won't be able to see something. We have circumvented that thing with the help of two basic arrangements. One, we have tilted the CRT to a particular angle, and then we have a sun guard plate at the top, which will help us in removing that problem. Features, to I think it's very small. So it's a compact design suiting to the express constraints of the LCA. I will skip these things, and these are the various modes of operation. You can have stroke mode, which is basically cursive writing. It's a scientific CRT. You can have cursive writing feature. Then there is a raster mode. In case of night flying, you have a FLIR camera installed at the front of the aircraft. forward-looking infrared camera. That camera captures the thermal signatures of the image. So when it is flying in the night, you can have that output of that FLIR camera onto the CRT screen, and in that way on the head-up display screen. So that feature is basically how your TV works. It's basically raster scanning. No? The beam starts at the top left and goes up to the top right, and then you have interleaving and all those other things. So similarly, we have provided that raster feature also in later versions of LCA. Initially, it was only cursor. Then there is a mixed mode. Basically, when raster scan is completed, it goes from top left, beam goes from top left to bottom right. And then there is a flyback period within which the beam flies back from the bottom right point to the top left point to start another frame. Within that flyback frame, when the raster is working, we can also have certain minimal cursive symbology displayed overlapped onto that raster screen. That is called basically mixed mode. And then another mode which we brand it as SBS mode, which will provide it with the standby symbology, which is internally generated, which is not coming from the aircraft sensors. This I can escape. This is basically the first flight of CSIO had with Sitara aircraft. So as I told you that for developing something for military is a very time consuming process, and any change which we pursue requires lot of considerations. It should be environmentally compatible, it should be electromagnetically compatible, as well as it should be certified from RCMA and DDAQA. So change does not happen very fast in our domain. We change gradually and slowly normally. And this built-in test equipment is basically an health monitoring system for the electronics of the head-up display. As I told you that head-up display is getting symbol information and 28 volt DC power from the air. We have installed the low voltage power supply, we have installed the high voltage power supply, as well as we have the CRT. Now what are the requirements of CRT? We have to protect it from phosphor burning. Phosphor burning may occur for lot many reasons, but simply if I concentrate the beam at a single point for a quanta of time longer than the required, it will burn. Then there is a sequence in which I should power on the CRT so that it does not get affected. That I need to control. Okay. Then there is a sequence which I should follow when I am stopping the system or when I am shutting down the system. So that is also done. Then signals are coming from the input, and finally after signal processing I am giving it to the power amplifiers for output onto the CRT. Now there can be two situations. Number one, signals are not coming from the background. In that case, my input may be a DC, and when I am getting a DC, and if I am navigating that DC onto the CRT, there will be a bright spot at the center, and after some time it will create a burn at the center. So I have to continually monitor the input that it is coming properly, and in case it is not coming, I should immediately switch on to the SBS. That is one scenario when my HUD is okay, but the signals at the input are not coming. Now there is another scenario that signals at the input are coming okay, but there is some problem with my signal processing circuitry, and at the output or where I do check mode I perform at the output of the signal processing part and at the input of the power amplifier part. So at that point, if signals are DC or not changing and they are okay at the input, what does it mean? It means that there is some problem with my electronics. Okay. So if it is some problem with my electronics or it is some problem with my device, there is a single golden rule that you shut down that LRU so that it may not cause any catastrophe to the aircraft. For any LRU, this is the golden rule in it. So one case I talked about is monitor mode, another case is check mode. Then there are high voltage power supply. They may also leak at times. They may also do blunders at times. So in each of these HVPS, LVPS, there are certain flag pins which indicate the health of those particular devices. So they also I need to monitor continuously for any faults. And if in case there is any fault, naturally something is going on wrong inside my electronics, what I have to do? I have to shut down. If something is going wrong outside my electronics, I can switch on to standby. Then one more feature which I talked about is automatic brightness control. So for that automatic brightness control, I have three modes basically: day, night, and auto. Day is maximum brightness, night is half of day, and then automatic is I combine the setting from the knob of the UFCP with what I have read from the sensor, the brightness. उसको combine करके हमने एक average out करके एक heuristic बनाया. Heuristic के basis पे हमने कुछ algo design किया हुआ है, and that we implement on it. So byte basically does what it does is on startup it performs a health check of the entire system. Then in the loop continuously it is monitoring the health of the input signals or status of the input signals. At the output it is continuously checking the output from the other electronics. At the same time it is scanning the health of the various power devices plus whatever setting I pass on from the UFCP and power port. So these all tasks are performed by the built-in test equipment. Power on self-test, subsystem health monitoring, automatic shutdown on subsystem failure, automatic brightness control, and phosphor protection of CRT by means of on-check functionality. This is a typical थोड़ा छोटा हो गया. So it's basically a combination of controller with a decoder as well as inputs from the UFCP port and the power port plus the DAC and ADC for managing those channels of monitor and checking. We have used basically we need mil standard things. Na? Our temperature range is -125 to +65 storage. So we are right now using 89C55WD. It has an inbuilt watchdog timer. Watchdog you might be aware, na? Do you know what is a watchdog? Basically, doctor cures everyone. What if a doctor himself is not well? So in case that controller software hangs, it would go into an infinite loop. To circumvent that problem, what watchdog does is it continuously triggers itself after a particular quanta. For instance, it triggered at 4th line, it will again trigger itself at 40th line. And we know that there are 36 steps between 4th and 40th line. And there is a buffer register which will go on counting, and if it does not reach 4 to 14, 36 steps, it means it is stuck up somewhere. So what it will do is it will reset the entire system, the byte system, or it will change the doctor if he is himself not well. Previously we used to use 8051 only, but since for that we need that watchdog circuitry outside the control system through a monoshot we used to provide. Now we are using WD, which has a inbuilt watchdog time. So this is the basic algorithm for the built-in system that initialize the mode status word variable and power up, set it to monitor mode, read the power port status. That is basically power port has the information regarding flags which are coming from the high voltage power supply, the low voltage power supply, as well as the EMI filter. Then read power port status, read UFCP status. UFCP you have to look for our data entry panel, which we call upfront control panel. So that UFCP will provide you information regarding the symbol brightness pot, as well as day night auto mode, as well as SBS mode and normal HUD mode. Set to check mode. In check mode, where I am checking the signals at the output just before providing those signals to the power amplifiers. Monitor X and Y inputs, update the MSW, monitor state word, and take appropriate decision. If mon is fail, what we have to do? Shift to the standby mode, and if check is fail, चेक फेल के केस में क्या करेंगे, सिस्टम शट डाउन करेंगे नॉर्मल. मैनेज सिंबल ब्राइटनेस by combining the input from the UFCP, whether we are in day mode, night mode or auto mode. If in auto mode, we have to consider both the sensor brightness input and the symbology setting from the UFCP. And then continuously we are running in the loop until the system is working. Another feature of which I have worked on is electronic standby side. So electronic standby side is basically a mechanism which is a great help to the pilot. I'm unable to show you one video. Actually, around 3-4 years we had a crash of the test flight, and the pilots have ejected, and still that was working into SBS mode. There's something has gone wrong with the control system of the aircraft. But up to the final point, whatever video they have provided, that is a restricted video, and so I didn't bring. So that shows that how it is helpful to the pilot in case of distress actually. Electronic SBS is an internally generated display page. It is implemented electronically. SBS mode is selectable from the data entry panel, and the pilot can switch over to the SPS as and when required. These are the basic stats for the electronic SBS. Depression shading 1 milliradian. Right now we have changed into a variable burn, that if I press the switch for a longer duration, it takes into steps of 10. Maximum depression angle of 240 milliradian. अब ये जो है, this data is basically based on the physical parameters of the aircraft. The maximum banking angle which the aircraft pilot may require, it is that setting. And the width of the aiming mark changes dynamically as it is pressed from 9 milliradian to 36 milliradian for a depression setting of more than 150 milliradian. I will show you visually, you will get better understanding. This is basically the standby side. It helps the pilot in taking landing decisions when and it will give it an idea about the angle of attack. So this particular the dynamic it starts from some 3.1 degree above the datum line of the aircraft. Basically जो nose होता है ना aircraft का, that is a very important axis. Aircraft की जितनी भी aerodynamic decisions होंगे, वो उस nose point के accordingly उसी पे उसकी CG होगी, सारे parameters उसी के हिसाब से set होते हैं. Now this is basically SBS हम लोगों ने डिजाइन किया था फ्यूचर को देख के कि हम आगे चल के डिजिटल हर्ड बनाएंगे. डिजिटल हर्ड और स्मार्ट हर्ड is something in which you don't need that display processor with the mission computer. That display processor is also embedded into the HUD itself, and you are directly interacting with the sensors. Sensor will give you the output data. You will process that data, convert into an image, and then display on the whatever display medium in future. It might be an LCD, it might be an OLED, whatever. So we used a DSP processor, ADSP2181, and it can integrate up to 256 devices. We have integrated only 2 switches right now in this version of HUD. In future we can enhance and use this processor to the maximal capacity, and this device generates the X and Y input required for the SBS symbology on a real-time basis, dumps onto these 4 buffers, and then first the data is generated into the upper 2 buffers, that is Y information, and then it is generated into the lower 2 buffers, that is X generation, and then parallelly at the same time it is ported to the next set of buffers, and then onto the DACs, digital to analog converters, because CRT is analog. Now what we have done is, in the current version we have replaced these 8 buffers with a FPGA chip. So our entire real estate requirement has in a way halved, and then onto the controllers. So in future, right now you are aware that we are having on-chip DSP processors and FPGA chips. So if they are available into mill, temperature requirements and other performance requirements, we can port this entire design in a single chip, and with multitude of device interface, it can have up to 256 IO device at a time. So many other functionalities of head-up display design, like those all cushioning and signal conditioning, that can also be embedded onto this particular part. So this is all about head-up display, and if you have any doubts, we can interact. I think I've not become a big barrier between you and your food. It's comfortable 1250. So if you have any doubts at the centers,
Connect them one by one.
First of all, Maharaj, one project.
so students, are you able to get what we have discussed, and if you have any doubts regarding this, you can communicate.
Government Polytechnic Maharashtra. Do you want to interact or do you have any doubts? In case you don't have, you can say no. At least we will come to know that you are listening. Mr. Nilesh Mose, are you there? Okay, we move to the next center. GIT Jodhpur.
Hello.
Good afternoon.
My question is, can we use it in marine or city transportation?
It's not clear. Your voice is not clear.
Can we use it in marine or city transportation?
You can use it in marine
And city transportation.
City transport.
City
You know,
transportation.
right now head-up displays are being used in certain high-end cars. Now utility of head-up display basically arises when you are traversing at a high speed or into certain conditions which are not favorable. In city transport, basically it can be used, but I doubt it is a lot useful, because basically the traversal speed in the city is not more than 30 kilometers per hour normally.
cost-wise also.
And cost-wise also, in city transport, if you would need another type of solutions.
Okay, thank you.
Thank you for your question. Now we move to the next center. MIT Meerut. Yes, sir. Yes, sir. No, sir, it's not audible. Oh, it's okay. You don't have any doubts. Okay. Next center, please. MMU Maulana.
No doubts, ma'am. Thank you.
Jaipur Engineering College. Jaipur Engineering College. Yes, Mr. Kumar.
Madam.
जी?
Hello.
हाँ जी, बताइए.
It was very clear and very nice presentation, madam.
Okay, I hope your students could get benefited from this, because today was your students' day also, no, for this.
Yes, definitely they will be benefited, because it was a new topic for them, and it was an introduction how they can go about it,
Okay. Thank you
and
so
where all virtual instrumentation or optical communication can be used.
Okay, thank you.
Nice presentation.
Thank you.
Thank you.
Item good now, Madam Amanpreet. Are you there? We can't see you. This is item good. Deed.
Hello, ma'am.
Yes, sir.
Now, lecture was very nice, but just we have asked one thing about if we are replacing the driver ICs with FPGA, does it make any difference in the efficiency of the circuit or not?
Question is that if we replace the driver IC of the FPGA, would it affect the performance? This is your question is?
Yeah, ma'am.
Over to you, sir. He's asking if we replace the driver IC of the FPGA, would it affect the performance?
Driver IC is such driver
So
IC.
what do you mean by the driver IC of FPGA? Could you please be clear about it?
I'm just away. Last section was told about the SBS current design. In that first circuit was implemented by using 8 driver ICs, and same circuit is removed by using a FPGA.
Yes, yes.
That is what our question is.
Basically, number one, real estate, the entire geometry in which we have to fit into the head-up display is very limited. In fact, if I consider it quantitatively, LCA HUD is twice the size of HJT HUD. And the envelope, since we are replacing an imported HUD, the envelope is fixed because we can't change the entire cockpit geometry for a single unit. So we didn't have the required space for those 8 ICs. So what we have done is, we have basically, you can see, instead of 8 ICs, these are representative sizes, but unless every buffer is has a particular physical form. So with that replacement, we have achieved that we have reduced the number of ICs used from a 8 to 1 IC, and
The
compactness has been achieved.
Okay, so thank you.
That is the main idea of replacing all those ICs.
Yes. It saves lot of space. Then it is configurable. You can configure every time. You don't need to change the entire. Plus, the installation is again on some plastic basis. In case of those, you have 8 installations and a single installation. It is more modular and more manageable.
Troubleshooting is more easier.
Easy, yes.
So for the things are finished. Is there any other questions, sir?
Most.
Okay. All the centers are done. Yes, ma'am. Now we also have our participants here. In case you have any queries or you want to interact with our expert, you're most welcome to do so.
For
today, and I would really like to thank our expert, Mr. Sandeep Singhai, who on a very short notice accepted our request to deliver this expert talk. And I hope you must have benefited a lot from his rich and vast experience in the field of head-up display. And in case you have any queries or you want to interact in future, you're most welcome. So, and we have timely wines. Thanks a lot for that. They must be feeling hungry. So now we break for the lunch break and we'll assemble here again at 2:15 for the next session. Thank you so much. Thank you.
बैक इंस्पेक्शन के चक्कर में जाएगा सर से पूछ लेना।
Yo,
A very good afternoon to all of you. Now we have come to the second half of today's seminar, and we have with us our expert, Dr. Mrs. Poonam Sial. And about her brief introduction, she is Associate Professor in the Electrical Engineering Department in NITTTRCHD, Chandigarh. She has more than 25 years of experience in this institute. She did her PhD in the field of electrical engineering, and her main areas of interest are renewable energy sources, energy management, um, assistive devices, women empowerment, etc. And today she'll be discussing with you the applications of microcontroller in the disability sector, a case study. That was her research work also. So I hope you'll have a good time. Thank you.
Thank you, Ritula. So, good afternoon, everyone. I welcome all the participants at the various centers which have been connected to our main center for this one-week training program, and also the participants who have come at our institute to attend this training program. So, my topic of today's presentation is application of microcontroller in the disability sector, a case study. In the previous lectures, you might have known that there is application of microcontrollers in various applications. Mainly, the topic might have focused on the industrial applications of the microcontroller. But another sector in which we can use the microcontroller in a very effective way is for the assistive technologies for the disabled persons. So I'm going to focus on the case study which is related to representing the graphics for the blind person, that is visually challenged person. वो कर So one of the main, as indicated in my the first slide, that is one of the main handicap which is towards the development or progress of the disabled person is our attitude towards them. And the main problem is the lack of accessibility of various assistive technologies which can enhance their access to education and employment. So this is a very good area for research and for also for providing the even you can think about giving the projects to your students or for doing the research work for the PhD level. And one of the problem which are being faced by the blind person is accessibility to the graphics. Since we all know that access to education, access to information and access to employment opportunities are crucial for our survival. And however, the differently abled, especially the visually challenged, they have very limited access to such opportunities. And one of the major barriers to their education is the limited access to the graphical information. Now, if we see the various modalities which are used for perceiving and receiving the information by our senses, these are touch basically, or through audio, that is hearing, and through vision. And one of the most important part which provides us the sensor input for information is eye. The information bandwidth capacity, if we see, it is the highest with vision, that is 1 megabit per second, while it is for audio it is 10 kilobits per second, and touch it is having the least information capacity of the order of 100 bits per second, and that too at the fingertip. Fingertip is the most, you can say, sensitive area which can access the information through sense of touch. Another powerful aspect of vision is ability to view many things simultaneously and to switch over quickly from one context to another. But this pseudo-parallel processing is missing in the other non-visual senses, that is sense of audio and sense of vision, touch. And the sense of touch compares to a very blurred vision at our fingertip, whereas audio is the problem with the audio information for the, especially when we giving it for use giving this information through audio to the blind person is it is sequential in nature. While as I've already discussed, the vision, we can see many things parallelly. And the one of the another eye-opening fact is that the largest number of blind population is in our country. About 20% of the blind persons of the globe are in India. And the problem is that in the disabled sector, only 1% of the disabled persons have access to assistive technologies. And the major reason is that either the technology which is available to them is very few in numbers, it is also very highly priced, and mostly it is imported from the other country. So their accessibility often gets reduced further. The challenging task is for rendering the dynamic graphical information for the blind persons. The major hurdle which is the lack of accessibility of graphics due to absence of vision. Now, why what is the significance of this graphics? Why do we talk about the problem of accessibility of graphics? Because our cognitive learning process, it is dependent upon the graphics for acquisition of knowledge and problem solving abilities. Graphics enhanced the understanding, as it has been referred in many research papers. It facilitates the organization of knowledge and it evokes the mental images. Many problem solvers, they depend on diagrams for spatial reasoning, and this graphics, they are formed into as a mental models in the short-term memory. And these mental models for cognitive learning, they are constructed in the short-term working memory, which has got a very limited capacity of acquisition of 7 or plus minus 2 new objects for 20 seconds. And the graphics are the means to reduce the short-term memory load. There are various types of graphics which we access to while we are studying. These graphics are classified according to their communication functionalities. One of the classified graphics is the decorative graphics. It adds to the motivation for learning, like the cover of a page of the book. Mnemonic graphics, they aid to recall factual information, like our menu icons on the software application, which is on the computer screen. Organizational graphics, they communicate structure and sequence of the subject matter, like this you can say timeline in the biography, or you can say contents in the tree diagram of the chapter. Then transformational graphics, they indicate the movement over the space or changing over the time, like the flow of the water in the water cycle, or the flow charts, which are used in computer science area. Relational graphics, they depict the quantitative relationships between two or more variables, like our line graphs or bar charts, etc. Another class of graphics is interpretative graphics. They represent abstract concepts or principles by schematic diagrams. For example, illustration of working of an engine or machine, like that. It is very complicated and time consuming to represent graphics non-visually, and so a single technology cannot represent all type of graphics in a simpler way. So one of the major graphics type of graphics, that is transformational graphics, organizational, relational, and interpretive graphics. They are the most important types of graphics because they promote the reasoning and deeper understanding to build up the knowledge, and these are most widely being used for the education purpose. And the area which I'm going to discuss today is on the representation of transformational graphics, or also commonly known as directed diagrams, and it aids in the intensive learning process. And these are generally represented in the form of nodes and their directional links. Now, the major application which is undertaken through the technologies using microprocessor is the representation of the flowchart. Basically, as you might be knowing, flowchart is a highly useful tool which is used in basic understanding of computer programming. It is a graphical representation which illustrates the sequence of operations to be formed to find the solution to the given problem, and these are also helpful in comprehending the logical flow. They are represented in standard two-dimensional shapes or symbols, and the blocks, they are connected through directional arrows to represent the flow of the process. Generally, we access two types of information in our daily life. One is textual, another is graphical, and this is we access either in the through static way or in a dynamic form. In a static way, as you know, it may be in the form of hard copy formats. It is in the tangible form, but it has a limited life. It requires some cost and time to produce and to make the copies also. And the accessibility requires the actual, that is physical exchange of the tool, and modifications are not possible once the static form is produced. While the dynamic information, it is mainly in the electronic formats, it is in the virtual form, it has unlimited life, and copies can be produced and distributed freely. It can be easily accessed through the net. And also modifications are easily possible at any point of time. In today's world, we generally access information in dynamic form electronically. Now the blind person, they generally access the textual information through Braille. As you can say, it is basically a combination of 6 dots, raised dots, and they are generally read by experienced blind person at a speed much slower than the speed by which we read with the help of our vision, that is by the sighted person. So they generally read at the speed of 100 words per minute, while the sighted person, they can read the print material at the speed of 300 words per minute. Now the dynamic textual information can be accessed by the blind persons using computer. One of the technologies through which they can access this information is refreshable Braille display. It can have the cells from 20 to 80 in numbers, and basically these, depending upon the Braille information which is there, the number of dots are raised up in the Braille display. So it also has a number of microcontrollers which controls the display of our pointers, or that is dots on the Braille display. Another technology which is quite mature is the screen readers. These are speech synthesizers like JAWS, that is job access with speech or narrator, and here the textual information is provided through voice. Through this technology, the blind person can access and generate the dynamic textual information without sighted assistance with the help of computer, but it is not in the case with the graphical information. Generally, the graphics information, it is accessed in the form of raised paper or embossed illustration, as you can see in the diagrams. These are generally simplified pictures. They can access very simple pictures, the blind person, but they cannot access the complicated diagram because they have to understand these diagrams by the sense of touch integrated with the audio. Now, generally these graphics, they are manually produced and they're prepared by the sighted person. And whenever the blind person accesses these diagrams to understand, then they require the continuous guidance from the sighted person through the exploration process, and at each point the sighted person explains the details and what is being touched by the blind person. It is very laborious to create these tangible graphics, and whenever they are created by the blind person, they always need reconfirmation from the sighted whether they have made it correctly or not. So it is not possible for them to create graphical information independently. Now there certain technologies have been developed to render the virtual graphics. So I'm going to discuss these in the slides which are commercially available. So one of the very, you can say, very successful technologies which can represent especially the maps for the blind person that is the refreshable full page display. It is available from NIST as NIST imaging systems. It has 3600 pins. Another similar technology is available from Matek, that is known as Matek Hyperbraille, which has 7200 pins. So it basically has a large array of closely spaced pins which can be raised in the pattern to represent two-dimensional image from the computer. Here it is possible to have full hand exploration of simple virtual maps and pictures via this display. But the problem is that it has a very high price, it has high power consumption and high maintenance cost also. Another technology which is having a lesser cost, it is for comprehending the virtual graphic, is VT player mouse. This device contains two tactile 4x4 array of individually controllable pins. As you can see in the diagram, on the top there is the black surface, and on the black surface there we have a 4x4 array of pins, and they provide the stimulation to the fingertips. Here the raised pin, it corresponds to the dark pixel, and the lowered pin corresponds to a light pixel of the computer image. The blind person places the index and middle fingers on these arrays to feel the tactile representation of images which are present on the computer screen. It has been used for comprehension of bar charts, pie charts and maps, and also when integrated with the audio cues. But however, it has not been found much effective because we have a small fraction of the full image which is presented through this device. So it requires a lot of mental effort to build up the complete graphic scene. Here the size and the resolution of array is too small. Other technology, this technology, that is VT player mouse, is also microcontroller based. Here we have a single microcontroller. However, our Matek Hyperbraille and NIST imaging system have a multiple microcontrollers, and that is why, because each pin has to be controlled individually. So that is why we are having high cost and high maintenance cost also related to it. And another low cost technology which is available is the Logitech Wingman 4 feedback device, which has been used for comprehending the virtual graphics by the visually challenged. It is also a single microcontroller based device. This device renders the graphics through single point contact, and it has been used to present effects such like of stiffness, friction, etc. during exploration of surface by the user. It has been used for comprehension of bar charts, of course, when it is also integrated with the audio cues appropriately. But however, it has been found that when unintentionally this mouse is lifted during exploration or navigation, it created an inconsistent mapping between the physical and virtual space. So that is why there was some problem with the understanding of given graphics was found. Another problem is, since it is a single point contact type of device, it requires high concentration from the user, and it is very memory intensive to build the mental model of the graphics by the blind person. So this shows that some research studies have been undertaken by using our appliances just discussed, that is for representing virtual line graphs and two-dimensional charts. But since these are the single point contact devices, so perception of the graphic is very slow, and it requires a lot of mental efforts by the blind person. Here this shows the Phantom Omni device for rendering graphics in the three-dimensional environment. Here the user controls the position of the pointer on computer screen and experiences force created by the electric motors in the device. The user interacts with the virtual objects through the stylus, and the workspace provided by this device is 16 by 12 by 7 cubic centimeters. So it provides 3 degrees of freedom force feedback along X, Y and Z axis. It has been used for exploration of the line graphs, bar charts and pie charts. Here also, because it is a single point contact device, so perception in three-dimensional space is very memory intensive, and also a lot of mental efforts are required. Another 3D other device through which the blind person can explore the graphics in the three-dimensional environment is Novin Falcon. The size of this three-dimensional workspace is 10.16 centimeters in each of the three directions. So it is having a smaller workspace as compared to Phantom. It has been used in the research for exploration of line graphs, bar charts, and pie charts. So with the help of our sound cues, and it is also a single point contact device. So same problem is there. Here also we have more number of microcontrollers, especially with respect to movement in the each axis, and Snowwind Falcon also have more than one microcontroller. Now, the most important aspect when we talk about the graphics is the mental mapping of the graphics. That is the, you can say, the core of representation of graphics by the non-visual modalities. This is very important to understand whenever we try to build up any device or assistive technology for representing graphics. Mental model construction is most crucial for meaningful learning, and this is constructed in our the short-term memory, which can be due to perception, comprehension, or imagination. And this has a very limited memory to process, which it can process just for 20 seconds. And then the blind person, they generally use external representations through non-visual, tactile, and with the help of speech and non-speech modality, as compared to the sighted person, which can use the diagram through the vision. In the absence of sight, the spatial aspects of diagram, it needs to be represented in a very effective way through non-visual modalities, which can help to form the mental models by the blind person. Now, a survey was undertaken before taking up the technology, which I'm going to just discuss you in a further slides. Here, the classroom observation was made, and also a questionnaire-based survey was done, in which the interviews were taken by the from the visually challenged persons. 45 persons were interviewed who were blind, and 10 teachers of the blind. And the persons who were blind, they were also interviewed. And after that, after observation and after their discussions and interviews with the target group, it was found that if we want to represent our two-dimensional graphics, what is the appropriate parameters based on which we can build up the assistive technology. It was found that the most commonly used diagrams, they were directed and classification diagrams. One thing I want to add here, that because of the loss of the vision, they have a very limited graphics understanding capacity, the blind persons. That is why across the world it is very difficult for them to go in for higher education in the field of science or mathematics. In India, like we have just they can just learn the mathematics and science till class 10th. Afterwards, they cannot be taught these subjects, although they have the intelligence to work in this area, to get to have education in this area, and build up career in this area. But the accessibility, because of the lack of accessibility of graphics, they cannot pursue their education after class 10th in the field of science and mathematics. So the most commonly used till they study the diagrams which they study is directed and classification type of diagrams, and the important aspect related to the understanding of these diagrams is to understand the complexity or the size of the diagram before going further. The spatial aspects, that is the comprehension of the layout of the graphic, how from the point where it starts, what are the boundaries, and what is the context of positioning of elements in the graphics in the given paper, that is very much important. And so there is a need to provide method for multi-context switching between the elements which are spatially placed in a given sheet. Another important aspect is the annotations. That is the description, brief description of the various graphical elements is very important, because they facilitate the understanding of graphics, and it should be under the control of the our user. Then another important aspect is that the user, that the blind user, they want to learn at their own pace. Otherwise, you see what it has been observed when you go to the classroom, which is in which the blind persons are being taught by a teacher, आपको ये दिखेगा कि they are dependent upon the sighted assistance, चाहे उन्होंने understand करना हो diagram या create करना हो. The sighted person always speaks out, and now suppose the blind person, he wants उसको पहली बार नहीं clear हुआ and he wants to repeatedly ask for the same thing from the teacher, but you see the teaching of graphics is also very tough for the teacher, because here the teaching takes place from one to one type. जैसे एक टीचर होगा और एक स्टूडेंट को पढ़ाएगा एज कम्पेयर टू द क्लास फॉर द अदर नॉर्मल स्टूडेंट्स. जैसे सभी around 30 to 40 students are sitting in the class, and the teacher just has to you can say show the PowerPoint or maybe show with the help of the blackboard or books he can teach. But for the blind person, for the graphics, it is very tough and very you can say time consuming to teach to them. Teacher has to call or sit with each student, and then he or she has to ask the student to touch the given diagram, which is tactile in nature, right? And whenever and wherever the student touch, the teacher explains the point, what is the importance of this particular part or the area which is under touch by the blind persons. So say it is very difficult for teacher also to repeat the same thing to each and every student, and for one student if he starts explaining again and again, so it is very much difficult for her. And this you can say this type of feeling, it also comes into the mind of the student, and they also feel demotivated when they study the diagrams. So this also hinders the understanding process of the blind person. So they want to learn कि हम अपने आप ही सीखना चाहते हैं, चाहे टीचर हमारा, what happens sometimes they think the teachers go ahead थोड़ा fast पढ़ा रही है, like that, sometimes teachers slow पढ़ा रही है, but they have their own speed of learning. So that is one of the thing that they want, step by step sequential graphical information they want under their control. They can understand it according to their, you can say, pace, their speed, and they want it to use independently. Now they are dependent on the sighted person, whether they want to understand or they want to draw a diagram. Then the convenient size, what is the convenient size which they can explore independently? It has been found that for tangible representation of two-dimensional graphics, it should be about the size of the hand to allow full hand exploration. It should be dynamic in nature so that the user should be able to create and modify the graphics dynamically, and the representation should be compatible with the tangible embossed graphics. Another important part is the user should be able to store a large number of graphics for a long duration, and graphics should be easily retrievable. When we talk of the static graphics, जो उनके generally क्या होता है, एक embossed paper पे एक paper पे embossed diagram होते हैं, dots होते हैं, थोड़े raised up dots होते हैं, उसके ऊपर they can touch and they can feel the shape of any diagram. Now what happens is, because they touch the embossed dots, after some time, because of touching and other thing, generally it has been found that the life of such type of diagrams sheet, you can say embossed sheet, is just 1 year. But if we store it in another form, like in electronically, then it has an unlimited life. So they want that it should be accessible to them at any point of time, convenient to them. Another thing that is very important is that the method, which the solution should be simple, it should be safe, and it should be low cost and easy to handle. That has been told by most of the teachers, because it is very important, because what happens is they generally produce graphics with the help of embosser. Embosser is a printed, you can say printer like we have, but it produces the print in the embossed shape, that is raised dots on the braille paper. Now it is very expensive and it is not easily accessible to a teacher, and there has to be a special software, although it can print the textual information easily, that is raised braille dot, but for printing the graphics there has to be a special software on the embosser, and since it prints in the sequential way, so it takes a lot of time for a teacher to access the graphics which are produced through this, and it is so they want that maybe the tool or the solution should be such which is low in cost and it can be easily accessed. So the approach which was used for non-visual representation of graphics was that in the absence of the site, for effective mental mapping of the graphics, it is necessary to develop a spatial workspace in the mind's eye of the visually challenged person, right? They cannot see, but in the brain they have to form a certain image of the workspace in which they can access the graphical information. Now the the graphic memory of the blind person is very underdeveloped. So this workspace concept should relate well to their general spatial experiences, so that they can easily understand it. It should be easy to mentally visualize and remain imprinted in the mind without overloading the short-term working memory. And it should also provide a sufficient number of uniquely identifiable and uncluttered facial positions, because when anything is cluttered, they cannot understand it, the blind persons. So what was done was a spatial grid-based workspace to represent virtual graphics were created with the array of 24 positions with 6 rows and 4 columns, and it was experimented with the blind persons, and it was found with the help of embossed paper that it was easy to comprehend and convenient for mental mapping and suitable for representing commonly used basic directed graphics. Now this picture shows the DGWIS system, that is Directed Graphics Visualization System, which was made for representing the two-dimensional directed graphics for the blind. As you can see, it has a software and certain hardware. It is microcontroller based. It is single microcontroller based device which is low in cost. So basically, the design guidelines behind this technology is a physically accessible virtual spatial workspace which was used for indexing textual information of the graphical elements. It provided backward and forward links and identification of subsequent and preceding elements, so that they can understand the direction of the flow of the algorithm, and they could also overview the layout of the graphics in the virtual workspace. The workspace helped them to navigate the various graphic elements independently, and also this workspace should be such so that it can be constructed and used for constructing and modifying the directed graphic dynamically without the sighted assistance. And this graphics which are produced, it could be saved also on a computer, and it can be retrieved also after that. And another parameter is to present the directed graphics in the traditional graphical format for sighted viewing, as well as the tactile embossing for the blind persons. Now this shows the block architecture of the DGWIS. Here, as you can see, DGWIS architecture is based on the novel methodology which maps the grid-based physical spatial workspace with identical virtual workspace. Here's the physical spatial workspace is workspace keypad, as you can see on your left side. It is a microcontroller based spatial tactile device which consists of two-dimensional spatial arranged array of 24 keys via push switches for generating spatial query and tactile inputs. On the right side, you can see the vibrotactile display. It has two sets of spatially arranged 4 vibrators for spatial vibrotactile outputs. And spatial tactile device is connected to computer via serial port. The firmware in the microcontroller of spatial tactile device, along with software front-end tool on the computer, provides physically accessible grid-based virtual workspace for spatial indexing of two-dimensional information and also for its further processing. Excuse me, ये इसको कर देंगे बंद, थोड़ा बहुत प्रॉब्लम लग रही है साउंड आ रही है. So the major features associated with the design aspects associated with the DGWIS system is that it has a low-cost microcontroller 89C52 with port lines for 24 push switches inputs, 8 vibrators outputs, and serial communication with the PC. The firmware in the microcontroller to detect the push switch pressing instant and also releasing instant, and then it transmits this information with the corresponding push switch position, that is row and column, to the PC for spatial positioning, for query processing, and user control over the speech and vibrotactile display. The firmware in the microcontroller is able to respond immediately whenever the command byte is received from the PC for display of column and direction vibrators to turn on or turn off the power of the respective vibrators, and it operates at a low voltage 5 volts, which is safe for the use. The spatial tactile device, it requires continuous interaction with the blind persons for tactile inputs and also vibrotactile and tactile outputs. So its mechanical design was finalized after taking average outlines of left hand of 28 visually challenged persons, and the superposed outline of these persons are shown here. So based on that, the dimensions of push switch array was finalized, so that it is convenient for the use, and it doesn't provide and it prevents the fatigue even for after the long usage by the blind persons. So this shows the push switch array, which is a spatial workspace suitable for full hand tactile exploration and for selection of the specific push switch by the visually challenged person independently. Here the visually challenged person can easily locate as well as mentally relate to the position of the push switch. The design of spatial vibrational display, as you can see, is divided into two portions. The upper section, it consists of 4 vibrators which are arranged in a structure denoting top, bottom, left and right directions, which denotes the direction of connectivity between the graphical elements. And the lower portion, that is below the 4 column vibrators display, we have it displays the 4 column position corresponding to the active element locations in the selected row of the graphics layout, and they are shaped so that each of our any of our 4 of the fingertips they can relate to the vibrotactile feedback given by the system. The PC software design has a virtual spatial workspace of an array of 24 positions, which can be used for creating, editing, and for understanding the graphics. It also has access to the required positions on the workspace to position the graphic elements and also its connecting elements. It has a command button to add and edit the required annotations to the graphic elements. It provides platform to edit and add type of graphic element for representing its geometrical shape also. It has an option for saving the position and connection details, its types and annotation of the element. It also facilitates handling of graphic data files, that is creating of new file, loading of already saved file, and saving of the file. In the software design, it also has an audio feedback, that is in the form of speech and also non-speech audio for positional layout of the graphical elements. It has a spatial vibrational feedback of positional layout. It provides spatial vibrational feedback of directional connectivity of the inwardly connected graphic elements. It also renders the spatial vibration feedback of positional and directional connectivity of the outwardly connected graphic elements. Here, guided navigation facility for comprehending the logical flow is also provided. Now, this slide shows the how this has been the rendering of the graphics, that is directed flow charts through the Digvis system. Here you can see that on the left side we have the output for the sighted person. This is also, this image is also generated whenever we have any flowchart created by the blind person. Just next to it we have a virtual workspace with 24 positions, and you can say the highlighted with the red color, these positions are the donates the presence of elements, that is wherever the flowchart elements are present. And you can see that this is correspond to the push switch keypad, that is if you want to have the overview of the leap year, like this example I have taken, it is of leap year flowchart. When we push one of the you can say key on push one of the key on the first row of our push switch keypad, then we will have a corresponding output in the form of vibrotactile feedback. This you can see on the right side, where we have a four you can say circles, and one red is highlighted. This shows the output signal is coming from the first one, that is on the four fingers. Here, as you can see, the element in the second row is present on the first position, and we press any key in the push switch, then only the we will have the vibrotactile feedback corresponding to the position of the element placed in that particular row. So similarly, by pressing any key in respective row, the blind person can have the feedback through vibrotactile modality, that to understand where the position of the flowchart element is there in the given graphic. So thereby, going in sequential way from one row to another row, it helps to form the mental model of the number of elements as well as the position of the elements in a given graphics by the blind person, and it can be done independently by the person without any sighted assistance. This slide shows that how we have this Digvis system. It facilitates the comprehension of the directional connectivity of the various elements. Here, the blind person, it gets a vibrotactile feedback for the connected elements directions and their position with respect to the decision element in the leap year flow chart. As you can see, when the blind person, they press the key at a position 1 of the element at the third row, then he or she will have the feedback on the vibrotactile display as it is indicated on the right side with the red dots on the vibrators. You can see it gives the indication of red dot that on the directional vibrators on the right side as well as bottom side. It means one of the output coming from this flowchart block is towards the right side, and one is just under the position is just under the block on which the person is keeping the finger, and another is you can also see where the position of the element in a particular column, that is the first and the second position where the flowchart blocks are present in the given graphic. Now this slide shows that the tangible flowchart image is generated in a way such that the flowchart illustration is produced in the traditional format for the sighted person, and also it is produced in an embossed way in the format with textual statement of the respected block in braille. So these are produced separately because so that the information generated is simplified and it is available in the uncluttered form for the blind persons to comprehend. Now this shows the front end of the software. The front end has been developed in Visual Basic and allows the user to comprehend, create and navigate graphics with spatial tactile inputs and outputs, with coordinated audio cues and speech information feedback in either through voice or through musical sound audio. And then the software integrates the spatial query and position inputs from the physical workspace of the spatial tactile device and maps these to the virtual workspace with graphics data on computer to generate tactile feedback through vibrations or audio information according to the function selected from the front end. Here, as you can see, that we have view graphic command button which generates the flowchart image. It can be generated for the sighted person. If you can see, there is a small and there is a braille written just below it. This, when we select this button, then the image in braille is created, and that this is it. This printout, the printout of this image can be taken with the help of embosser. Now there are certain command buttons for handling the graphics data file. Like we have the if we want to create a file, there's a new graphic, or we can load the graphic file which has already been saved, and we can save the once we just enter all the required information, the file can be saved also. So these command button, as you can see, for handling the files, we can see it on the screen. So the sighted person can select the command button and it will be executed. For the blind person, there is assigned key. If you will see, maybe this is having a smaller resolution, but on the you can see there is one of the word in the command button is underscored, underline. So what does it do? It is what does it indicate? That it indicates that a blind person can select this particular assigned key. Like generally what happens, he suppose he want to create the new graphic, he can press the he can press Alt G, through which automatically new graphic file will be created. So similarly, he with continuous usage of his this software system, he remembers, because they have got a very sharp memory. I have worked with them and I have experimented with them also for evaluating this. And you will see also there is a video after this presentation that how they can, without any guidance, they are using it independently. They will remember all these things very quickly. They have this very sharp memory, the blind persons. So there are here we have command buttons for comprehension of position of the graphics. So it can be the person can listen to the audio output either in the form of speech or in the form of non-speech sound. So depending upon his preference or her preference, he can select the command buttons. Then we have the command buttons for comprehension of the graphics data by special query mode. That is, we can understand what is the layout, what are the particular, if a particular element details, what are the brief about each element, and also what are the connected element to the selected element, what are the connected which are subsequent later on, or previous elements connected to the selected element by the blind person independently. So this is here another, you can see, set of command buttons which are used for creating and editing the graphic elements. Here first the element position is selected by the blind person either through the push switch or through particular selecting this particular, he can enter the position through software, and then he can enter the element name. After that he can enter the element type, like it is input, output, or decision block. Then he can also enter the element statement, what is written in that particular block, and after that he can also connect the next element to the specified element. And since the simple flowcharts was evaluated and used for this in the system, like this leap year and greater of 2 numbers and so on, and so here their options are given for connecting 2 elements to a given element. Now there is also a command buttons which facilitate the guided navigation for the blind person. A person can simply select the first element, and thereby through using the command button of next connected element, automatically the system indicates what are the next elements and what are the annotations and other features related to a particular elements, and thereby he can also go forward or backward through the flowchart to understand it as many times as a person wants. Then on the right side, extremely right side, you can see virtual 2-dimensional spatial workspace with 24 positions. So this is the you can say which this is just corresponding to the push switch array which is provided, which can be accessed through touch, or he can also again through the assigned key can select the position of each of the spatial workspace for which he can select the position of the element to be placed. Right, and then he can clear also, if he want to modify, he can clear the details of the element also by using the current command buttons for creating or editing of the graphic elements, and then he can save. So thereby he can make the this graphic, that is the directed graphic flowchart, block by block himself or herself independently. So the software is designed so that the system is accessible and user interactive with appropriate fusion of non-visual modalities. So the command button for generating the flowchart image, it as I have already discussed with you, it can create the traditional flowchart image for sighted viewing, or it can also create it in the braille form. So evaluation of this system was also done with respect to representation of spatial aspect of the directed graphics. There are two important parts related to the spatial aspect. One is layout, that where at which positions the elements are placed. Another is the directional connectivity, that is how in which directions the elements are connected with each other. The experimental study was done with 28 blind persons. Uh, Here I will like to add that 21 congenitally blind persons were there, 3 was eventually blind, and 4 were visually impaired. Now, what is the difference between these two categories? Congenitally blind are those persons who are blind from an early childhood or from the since the birth, and the persons who are later they get blind, they are known as eventually blind persons. And the congenitally blind persons are having more tough time because their mental this graphic memory is very limited, because they have not seen anything till since they are very small. So it is very difficult for them to understand anything graphically, especially graphic based. So it is very important that when we do any experimentation with respect to assistive technology, then we should have congenitally blind persons also considered for the testing. So here it was tested in two conditions, with spatial tactile device with audio feedback, and another condition was spatial tactile device with spatial vibrotactile feedback. And the result shows that if you can see the blue lines, it is just the audio feedback was there without any tactile device, just like the teacher guides them, right? Just by telling only, by voice only, you can say, or by speech only. So meantime, and the green one that shows the when vibrational output was also given, so that they can understand the layout and the connectivity among the elements. That it shows that it has much less mean time to understand the positional layout of graphic as compared to when we are telling them only with the speech. It was also found that the percentage of error performed in the task, in the given task, it was given layout, 3 types of layout were given. One was for the small number of elements, and one was for the medium, and one was for the large number of elements. Small contain around 6 to 8 places, medium around 11 to 13, and large contain more than 20 position of the elements. So these 3, small size, medium size, and large size, the errors were also noted down. And it was here also it was found that vibrational feedback with spatial tactile device, it make the understanding more effective. Now the time taken to understand the directions also was found to be quite less when the device was used with vibrational feedback as compared to only speech feedback without the spatial tactile device. This again shows that the errors with respect to the directional connectivity among the elements were less when the spatial tactile device is used with the vibrational feedback. So the results in the graphics just indicates that the blind person could easily form the mental model of the spatial aspects of the virtual graphics independently using array of 24 keys on the workspace keypad. It was convenient to access the absolute positions on the workspace through push switches by them. The multi-context spatial query methodology, it facilitated the comprehension of the spatial aspects of the graphics. The workspace keypad, it allowed for easy full hand exploration. The 4 fingertips was conveniently placed at appropriate positions of various vibrators independently without any sighted assistance, and it could be used conveniently and independently and did not cause any fatigue to the hands. It also reduced the mental fatigue of the blind persons. Now another experimentation which was done was that a single user, a blind person, could comprehend and create the flowchart independently. Here it could, there 2 experimentation stages, types of method were used. One was through Digviz, that is the system which was developed, and it has the patent pending technology. And another is the embossed output, the tangible flowchart which was created with the help of this particular device, and then it was given to the blind person. And how what is the difference when we use these 2 methodologies to understand the graphics and to produce this with the Digviz? However, as you can see that the sighted user is required when when any blind person they try to understand the graphic output in the form of tangible output. This video shows a blind person who is using DIGBIS system to generate the graphic which he has understood with the help of DIGBIS system.
मेरा नाम लाल सिंह है और मैं इंस्टीट्यूट फॉर द ब्लाइंड सेक्टर 26 में 11th क्लास में पढ़ रहा हूँ और मैंने इस सिस्टम के जरिए फ्लोचार्ट बनाना सीख लिया है और मैं इसको बना रहा हूँ। इससे हमें ये पता चलेगा कि एज के अकॉर्डिंग कोई पर्सन जो है वो बोर्ड दे सकता है नहीं।
OT edit R1C1 type in text OT edit enter the current block location type in text edit OT edit enter the block type START all then edit enter the block statement type in text START edit type in text edit type in text edit R2C1 type in text edit type in text Alt 1, edit, R2C1, type in text, Alt D, edit, type in text. Edit, R1C1 block type is start block code, start its outward connected, block 1 is an R2C1 which is noun, type in text, edit, type in text. Edit, R2C1, type in text, edit, Alt D. Edit, enter the current Alt T, edit, enter the block type, INTUT. Alt N, edit, enter the block ENTER, space THE, space AGE, space IN, space YEAR, S. Edit, R3C1, type in Alt 1, edit, R3C1, Alt D, edit, type in text. Edit, R2C1 block type is input, block code is enter the age and years itself word connected, block 1 is an R3C1 which is noun, type in text, edit, type in text. Edit, R3C1, type Alt T. Alt T, edit, type in text, enter the block type, edit, DECISION. Alt N, edit, enter the block statement, IS space AGE space GREATER space EAAP backslash B AH T space THAN equals 1 8. Edit, R3C1, type in text, edit, type in text. Edit, R5C1, type in text, edit, type in text. Edit, R4C1, type in text, edit, type in text. Alt 1, edit, R4C1, type in text. Alt T, edit, type in text. Edit, R4C2, type in text, edit, Alt 2, edit, R4C2, type in Alt T, edit, the current block position is an R3C1, its block type is decision, its code is age greater than equals 18, its connection 1 is R4C1, type in text. Edit, R3C1 block type is decision, block code is age greater than equals 18, its outward connected, block 1 is an R4C1 which is noun and outward connected, block 2 is an R4C2 which is right, type in text, edit, type in text. Edit, R4C1, type in text, edit, type in text. Alt T. Edit, enter the Alt T, edit, enter the block type in text. O-U-T-P-U-T. Alt N, edit, enter the block statement, type Y, O-U, space E-A-N, space E-O-T-E. Edit, R5C1, type in text, Alt 1, edit, R5C1, type in text, Alt D, edit, the current block position is an R4C1, its block type is output, its code is in control, type in text. Edit, R4C2, type in text, Alt D. Edit, enter the current block location, type in text. Edit, the current block position is an R4C2, type in text. Alt T, edit, enter the block type in text. O-U-T, space, P-U-T, Alt M, edit, enter the block statement, type and Y, O, U, space, C, A, N, space, N, O, T, space, B, O, T, E. Edit R5C1, type and text, edit Alt 1, edit R5C1, type and text, Alt P, edit, the current block position is an R4C2, block type is unquote, its code is in not its connection 1 is R5C1, type and text. Edit R5C1, type and text, edit Alt P. Edit, enter the current block location, type and text, edit, type Alt T, edit, enter the B, N, D. Alt M, edit, enter the block statement, type and text. E, N, D. Alt D, edit, the current block position is an R5C1, its block type is end, its code is end, type and text. Alt S, save as dialog, file name colon edit combo, E colon backslash QPASIC backslash it dot dat, 0 items, to set the value, use the arrow keys or type the value, Alt plus N. L, A, B, H, space R, A, N, A, period, D, A, T. Enter, edit, E colon backslash QPASIC backslash lab run dot dat, type and text. Alt V.
मैंने ये फ्लो चार्ट बिना किसी सेटेड की मदद से खुद बनाया है इस सिस्टम के जरिए, और मुझे इस सिस्टम में काम करना बहुत अच्छा लगा और मैं इसके लॉजिक को समझ सका हूँ और मैंने इसे समझ लिया है और मुझे बहुत इंटरेस्टिंग लगा और आगे भी मैं कंप्यूटर साइंस में पढ़ाई करना चाहता हूँ.
So as you have seen in the video that with suitable speech cues which were present with the help of the software and the hardware which provided the spatial tactile input as well as output, the blind person can easily and independently they could create and understand the flow chart. Excuse me, इस पे फोकस कर देंगे. One more video films are to be displayed. आप उस पे फोकस कर दीजिए slides पे. So another output which was also available with the help of the device Digvis is the tangible flowchart, in which the shapes and the flowchart shape in the traditional format was presented, and also the related corresponding text to the each flowchart block was presented in a different sheet. And you can see then but here the blind person needs the sighted assistance to understand it. And this you will see the comments of the
इस सिस्टम में से ये भी एक आउटपुट निकली है और उसे तो मैंने समझ लिया है, पर इसको समझने के लिए मुझे किसी साइटेड की जरूरत है और एक बार अगर ये समझ आ जाए तो उसमें काम करना बहुत इजी है और मुझे ये सिस्टम बहुत अच्छा लगा और बहुत इजी लगा. थैंक यू.
So as you have seen in the two slides that the video films that the blind person can independently understand, because after understanding this graphics directed graphic from this system only, one of the blind person has generated the flow chart as shown. And then the evaluation was done in which it was found that comprehension time with the Digvis system, that is through spatial tactile device and sound feedback or speech feedback, it was done with the 8 visually challenged persons. It was found that it took around 2 minutes less as compared to the tangible graphical output, embossed output, which you have just seen when it was experimented with 7 visually challenged person. And the creation time, because it can be created independently only with the Digvis system, a blind person cannot create it even with the help of sighted person, the flow chart. So the creation time was around 14 minutes. So the qualitative analysis of this study shows that the visually challenged could independently understand the flow chart and create it as well as edit the same with the help of Digvis. And they were really happy, as you have heard one of the person, because it really provides the feeling of self-confidence, self-esteem and motivation when you are independently working without any sighted assistance. And there, even the teacher also, she used this technology to make the student understand the flow chart. And some of the remarks which has been said is, I'm just showing.
Myself Nirmala, मैं इंस्टीट्यूट फॉर द ब्लाइंड सेक्टर 26 में जो है वो कंप्यूटर साइंस की टीचर हूँ। कभी भी हम प्रोग्रामिंग में कोडिंग बच्चों को सिखाते हैं तो सबसे पहले जो है उनको फ्लो चार्ट हमें सिखाना पड़ता है एज ए डिजाइनिंग टूल। लेकिन एक विजुअली चैलेंज बच्चे के लिए जो है वो फ्लो चार्ट में डिजाइन बनवाना जो है वो इम्पॉसिबल वर्क है, क्योंकि विजुअली इम्पेयर्ड चाइल्ड के लिए जो है बहुत मुश्किल होता है ग्राफिक्स को समझना और ग्राफिक्स को बनाना। तो ये पॉसिबिलिटी जो है वो मेरे पास नहीं थी कि मैं एक फ्लो चार्ट जो है बड़े अच्छे ढंग से जो है वो बच्चों को समझा सकूं या उनसे बनवा सकूं। बहुत मुश्किलें फेस करनी पड़ती थी और बहुत मुश्किल से जो है ये काम जो है वो पॉसिबल हो पाता था। लेकिन अब जो है वो इस टूल की मदद से जो है वो फ्लो चार्ट जो है बच्चे बहुत ईजी से बना पा रहे हैं। इस डिवाइस के थ्रू जो है बटन्स के थ्रू है फ्लो चार्ट की किसी भी लोकेशन पे वो जा सकता है और किसी भी लोकेशन को एडिट कर सकता है, उसको दोबारा से जो है वो क्रिएट कर सकता है, मूव कर सकता है। और साथ ही साथ में जो है वो हमारे पास जो भी यहाँ पे फ्लो चार्ट बनता है वो जो विजुअली इम्पेयर्ड चाइल्ड है उसके लिए तो एक स्टेटमेंट वाइज बनता है, कौन सी स्टेटमेंट किसके बाद आ रही है। लेकिन एक साइटेड टीचर के लिए जो है वो ये भी है कि ये ग्राफिक्स फॉर्म में शो हो रहा है। ग्राफिक फॉर्म में शो होने की वजह से जो है साइटेड टीचर बहुत ही कम समय में जो है वो इसको इवेलुएट कर सकता है। साथ ही साथ जो है जो ग्राफिक फॉर्म में एक्चुअल में फ्लो चार्ट दिख रहा है उसकी जो है एम्बॉस आउटपुट आ जाती है प्रिंटर पे, तो बच्चा जो है वो अपनी फिंगर्स के थ्रू जो है उसको जो है वो समझ भी सकता है कि एक्चुअल में ग्राफिक है क्या। तो इस सॉफ्टवेयर की वजह से और डिवाइस की वजह से बहुत ईजी हो गया है फ्लो चार्ट को एक विजुअली चैलेंज बच्चे को बनाना। मैंने जो है वो एक साथ 2 बच्चों को समझाया और 2 बच्चों ने जो है वो यहाँ भी जो है पहले एक फ्लो चार्ट पे काम करने के बाद खुद ब खुद इंडिपेंडेंटली इजीली इस सॉफ्टवेयर इस डिवाइस की मदद से लीनियर पे जो है वो खुद ब खुद एक बार मुझे लॉजिक उनको समझाना पड़ा। आफ्टर दैट उन्होंने बड़े आराम से जो है वो फ्लो चार्ट जो है वो बना लिया और बहुत अच्छे से जो है वो उन्होंने चीजें ग्रैस्प कर ली। क्यों? क्योंकि ऑलरेडी जो है वो बच्चे जो है वो जॉब्स के थ्रू जो है वो कंप्यूटर के साथ फैमिलियर हो चुके हैं। तो यहाँ पे जो है वो फ्लो चार्ट के सॉफ्टवेयर फ्लो चार्ट से जो देखिए सॉफ्टवेयर का डिवाइस है इसको भी बनाने में उनको जो है सॉरी इसको भी करने में उनको जो है ज्यादा टाइम नहीं लगा, बहुत जल्दी वो सीख गए। और सीखने के बाद इंडिपेंडेंटली उन्होंने जो है ये मुझे फ्लो चार्ट जो है वो बना करके बताया और आफ्टर दैट मेरे लिए भी इजी सेव हो जाता है और मैं उनको असाइनमेंट दे सकती हूँ और असाइनमेंट जो है बाद में जो है वो कभी भी अपने कन्वीनियंस के अकॉर्ड में उनसे जो है वो चेक कर सकती हूँ। और साथ ही में जो है वो इसका बेनिफिट ये भी है कि हर एक बच्चे को जो है मुझे इंडिविजुअली जो है वो नहीं ट्रीट करना पड़ता। मैं ग्रुप में एक स्मॉल ग्रुप में जो है वो बच्चों को समझा सकती हूँ। एक बार सबसे पहले जो है वो डिवाइस से जो है उनको रूबरू कराना पड़ता है। आफ्टर दैट वो जो है वो इजीली जो है वो लॉजिक क्लियर करवाने के बाद जो फ्लो चार्ट जो है वो आराम से बना पाते हैं। मैं एक बात और बताना चाहूंगी कि फ्लो चार्ट का कंसेप्ट एक बार बच्चे को क्लियर हो जाता है तो उसके बाद जो है उसके लिए जो है प्रोग्रामिंग जो है वो बहुत इजी हो जाती है। तो प्रोग्रामिंग अगर इजी होती है तो आफ्टर टाइम जो है बच्चा जो है कंप्यूटर साइंस डिप्लोमा जो है वो ज्वाइन कर सकता है एक विजुअली इम्पेयर्ड होने के बावजूद भी। और साथ में उसके लिए जो है एजुकेशन में और एम्प्लॉयमेंट में जो है काफी जो है अपॉर्चुनिटीज जो है उसको मिल सकती हैं अगर इस सिस्टम को जो है वो एक बच्चा जो है वो यूज करता है। काफी जो है इम्पोर्टेंस है सिस्टम की, क्योंकि प्रोग्रामिंग लैंग्वेज जो है वो कंप्यूटर का कोई भी कोर्स है उसमें जो है एक जो है वो रीढ़ की हड्डी का काम करता है। तो ये जो है बहुत ही जरूरी चीज है कि एक बार जो है वो फ्लो चार्टिंग का कंसेप्ट क्लियर है तो बच्चे की प्रोग्रामिंग लैंग्वेज पे पकड़ है, प्रोग्रामिंग लैंग्वेज पे पकड़ है तो वो अपना सॉफ्टवेयर डेवलपर्स की तरफ भी मूव कर सकता है और भी एम्प्लॉयमेंट में जो है उसके जो है वो रास्ते जो है वो खुल सकता है।
So the teacher also commented upon the effectiveness of this tool for teaching flowcharts to the persons without vision. And another important attribute of this device is the low cost, as you will see when we compare it with other devices available in the market, like Matic display with 7200 pins, and that is full page refreshable tactile display for exploration of virtual 2-dimensional maps or diagrams that has been used. And similarly another system that is NIST pins down imaging system with 3600 pins has been used, but they have certain limitations, although they are very effective for understanding these simple maps and diagrams. But the problem is the high cost, the maintenance cost also, initial cost also, and high power consumption. It has got a number of microcontrollers because each pins has to be individually controlled. and the cost is approximately, that is around $50,000 of METIC display, and the NIST it is around $15,000. And when we talk about another assistive technologies, that is the single point tactile exploration in the three-dimensional space, which has been used for rendering the shape and two-dimensional simple charts, that is Phantom Omni. It has been used, but it has limitations that perception of the space is slow, since this is also single point contact device, and it requires a lot of efforts on the memory, and the cost approximately is 10,000, although it varies depending upon the type of the model. Another, it also has a depending upon the number of axes, multiple microcontrollers. This VT player mouse, it is also based on the single microcontroller. It has got two 4x4 pins array. Here we use two fingertips textile displays for exploration of two-dimensional virtual simple maps, line diagrams, and charts. But since it is also a single point contact, so understanding is slow and memory intensive. And another limitation is that the mouse use is confusing when it is lifted up, and it has a limited workspace operation, and the cost is less. It is around $1,000. The Logitech Force feedback mouse is of a lesser cost, around $100. It is also a single point force feedback device, which has been used in research for exploration of two-dimensional virtual simple lines, diagrams, and charts. But since it is also a single point device, so it requires a lot of mental efforts to build and comprehend the complete scene by the visually challenged, and mouse use is confusing when it is lifted up. Now this system, it has features which through which the graphics can be comprehended, created, and edited. The virtual two-dimensional directed diagrams without the sighted assistance, and this can also be used for organizational diagrams, bar chart, and spreadsheet. But the limitation is that it does not render the virtual shapes of the elements in the directed graphics, and the cost is around $35. So this device, it provides it has the scope of scalability. So thank you so much. I will just conclude this my talk with the small video. सेंटर्स पे
we have MMU Mulana, Jaipur Engineering College, and Government Polytechnic Maharashtra, JIT Jodhpur, Meerut, and Meerut. Yes.
Now we'll have a questions answer session. Any question from center at Maharashtra? From government? Yes, please. No question? Okay, we'll move to next center. From the JIT Jodhpur, any question?
No, thank you. I would like to first of all wish you very happy participants there, and I would like to tell you that people are constantly working on microprocessors and microcontrollers. Under the guidance of faculty members, students have worked on hydraulic bed, it's an automatic hydraulic bed and wheelchair based on the mouse movements. And as we have got a very good idea from the presentation, we could try to develop a project based on which will work for visually impaired persons. Thank you very much.
So thank you so much. We'll move to next center. हाँ जी, मेरठ Institute of Engineering and Technology.
Hello, ma'am.
Hello.
Thank you, ma'am. It was a very useful session for us.
Thank you. So we are moving to Maharishi Markandesh University, Mulana. Any questions?
Yeah, ma'am, it is very good session, and it was very interesting subject and topic also. We are very much thankful to you.
No.
ITM University, Gurgaon.
Any question from ITM University, Gurgaon, please?
Hello.
Hello.
Ma'am, it was very informative session on this physically challenged, as it is very emerging technology. I just would like to ask one question, that whether we have anything for deaf and dumb which you have developed or you have surveyed on?
I have not. I understand. I understand. At this, I have not done research in that particular area, but of course, what I can understand is the visual form in this tool can be used along with the vibrotactile feedback for this particular application. But as such, any other information regarding to their assistive technologies, I don't have much idea about that. Sorry about that.
Okay, thank you so much, ma'am.
Thank you.
And we have one more center, Jaipur Engineering College.
Jaipur Engineering College.
Yes, hello.
Hello.
Yeah, that was a very interesting session, and we would like to know whether there is any scope in extending this subject for the project work. Can you suggest some of the ideas so that we can extend these ideas as project?
Okay, this is about the graphic representation. Another area of research which I can suggest you is the this with regard to their movement. You can say like when they want to cross the road, they want to know whether vehicle it is safe to cross the road, or is there some problem is there, maybe रास्ते में if some problem is there, like कोई खड्डा है या कोई obstacle है that they cannot see. So another area is the with regard to their movement. That also is a research area in which the projects are being undertaken and research is being done.
Here, I would also like to supplement what ma'am has said. One of our ME student has also worked on this. He made one microcontroller based cane for the blind people, and in case any obstacle comes, then it used to it had some sensors, and it used to give a sound and tell the blind person that be careful, there is some obstacle, and such kind of thing. It can be developed.
Okay. Thank you so much.
Thank you. Any questions from this our participants from here? So thank you, everyone.
Thank you so much, ma'am. I would like to thank our expert, Dr. Mrs. Poonam Sial, for enlightening us with such an innovative idea, and also giving you an insight into the world of disability sector, how the embedded system can help them, what more future areas are there which can be developed around microcontrollers, which can help the disabled people. In fact, differently able people, I would say. And thanks again, ma'am. Thank you a lot.
Thank you for giving me the opportunity.
Tomorrow we have embedded system ARM. So ARM microcontroller is going to start from next day, and we have a team coming from Bhopal. So we'll again meet tomorrow. Thank you so much.
Thank you, everyone.